Hello there and welcome to the Sleepymentary channel. Tonight we're not just staring at the night sky, you're floating in it. Every breath you take rides on a planet that spins inside a galaxy, that drifts inside a universe that's still stretching like taffy, warmed by invisible hands. Out there beyond the reach of even your most reckless daydreams, everything is sliding away from everything else. And no matter how fast you try to chase it, you could never catch up. You probably won't survive this one, at least not the part where we measure time in billions of years and distances in light. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're listening from and what time it is there, because somewhere someone else is watching the same stars in a different tomorrow. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first thing you notice is that silence in space isn't really silent. It's filled with the faint hiss of microwave radiation, leftover heat from when the universe was barely out of infancy. Imagine you're lying on your back floating, and the air around you hums with a temperature just above absolute 2.7 Kelvin. That faint warmth is cosmic history still cooling. Every particle of you, every atom in your bones was once suspended in that primordial glow. You blink and the sky above isn't an empty dome anymore, it's breathing. You can almost see galaxies shifting, not spinning like ballerinas, but receding, stretching the very fabric that carries them. The expansion isn't just out there, it's here between your eyes and the screen between molecules in the air. Scientists call this the metric expansion of space. You could think of it as the universe's pulse, an unending inhale that started 13.8 billion years ago and hasn't exhaled since. Here's the mainstream fact Edwin Hubble first spotted that galaxies were receding from us in the 1920s. The farther away a galaxy was, the faster it seemed to move. It wasn't that we were at the center, everyone sees the same effect. Space itself is stretching like dots drawn on a balloon as it inflates. That simple discovery rewrote our cosmic address. But here's the quirky twist: before Hubble, Einstein himself had tried to keep the universe still. He added a cosmological constant to his equations, a kind of mathematical anti-gravity, because he thought a static cosmos made more sense. When the expansion was discovered, he called that constant his greatest blunder. The irony that so-called blunder might actually describe dark energy, the very thing still driving the expansion today. Physics loves a good redemption arc. If you could float above it all, watching galaxies drift apart, you'd see the universe not as chaos, but as choreography. Clusters move like slow dancers that never touch again. The spaces between them widen, not because they push, but because the stage itself grows. Every second distant galaxies move away at thousands of kilometers per second, and yet locally here in our tiny corner, gravity keeps things cozy. The Earth clings to the Sun to the Milky Way, and the Milky Way to a cluster that stubbornly resists the grand drift. You might say gravity is the universe's love language, clingy patient, unwilling to let go. Scientists still argue whether the universe's expansion will go on forever or someday hit a cosmic speed bump. Some models suggest dark energy could change over time, a quintessence that grows stronger or weaker. Others think it's just the geometry of space settling into its long future. Either way, you're living inside a story that's still being written in wavelengths and whispers. It's easy to imagine the universe as something external, a vast aquarium, and you, the curious fish. But in truth, you're part of the water. Your body, your breath, even your memories are small ripples in that same fabric that expands. When you think about your own life stretching out in time, it's not so different from the way space stretches in volume. The past doesn't return. It moves away, redshifting into memory. A cosmic joke for the night astronomers like to say the universe is expanding faster than their grant budgets. And like the cosmos bureaucracy also seems to accelerate for no clear reason. Still, both keep us humble. Somewhere far beyond your perception, galaxies that once shared the same cosmic neighborhood are now moving so quickly that their light will never reach us again. They slip beyond what physicists call the observable universe, a boundary not of things, but of time. You can think of it as the horizon of cosmic memory. Beyond it, light simply can't outrun the expansion. It's gone not because it died, but because it can no longer find us. You float there a while, feeling a strange empathy for photons that left their homes billions of years ago, carrying messages they'll never deliver. Each one began its journey before Earth had continents, before eyes had evolved to see. And yet here you are catching them on your retinas, turning their silent flight into meaning. That's the quiet miracle behind every stargazing night. You're not looking up, you're looking back. The expansion continues even as you breathe slower, as if your own pulse sinks to it. You can almost hear it not as a sound but as a thought stretching across time. The universe expands and you drift with it, never still, never separate. And somewhere deep in that stillness a single idea flickers. Maybe the reason the universe never looks back is because everything it ever was is already inside you, humming softly in the atoms that remember the first light. You follow one of those ancient photons. It left its home long before your planet was born, long before the sun gathered its flame. It's been travelling for 13 billion years, steady as a heartbeat, that never stopped crossing a universe that keeps stretching under its feet. The longer it travels, the redder it becomes, its wavelength pulled like a violin string loosening in slow motion. Somewhere along the way, it passed through galaxies that no longer exist, then clouds of hydrogen that never became stars. And finally tonight it slips into your eye, a faint, exhausted messenger whispering, "I've been running since time began." Light has memory, but no rest. It tells you stories of a universe that's constantly moving away from itself. Every star you see tonight is a fossil of light showing not how it is, but how it was sometimes billions of years ago. That's the quiet trick the cosmos plays. You never see the present. You only see the light that left before you existed. Mainstream science fact for the night light travels at 291,792 kilometers per second, a speed that's both absolute and untouchable. It's the universe's built-in speed limit. Einstein's special relativity tells us that nothing with mass can reach that velocity. Time would stop for it, and energy demands would go infinite. Yet light has no mass, so it dances on that knife edge, perfectly slipping through the rules without breaking them. Now the quirky part, some researchers have wondered whether light might slightly change speed depending on energy. A hint that space-time itself has texture like a fabric made of plank-sized threads. If true, the highest energy gamma rays should arrive microseconds earlier or later than expected when travelling from distant galaxies. So far, we haven't caught them doing it. But the debate lingers, the sort of cosmic gossip physicists love to argue about at 3 a.m. conferences. You close your eyes for a moment and imagine that photon's journey. It doesn't move through a static emptiness, it rides a river that's widening every second. The farther it travels, the longer the space it must cross becomes. It's like running on a treadmill that's stretching beneath your feet faster and faster. No wonder cosmic light arrives, tired, stretched, its colour shifted toward the red. That's what astronomers call cosmological redshift, the signature of expansion burned into the spectrum itself. It's hard not to take it personally. The universe isn't just moving away, it's also aging, and because of that, you can never go home again to how the sky once looked. There was a time when the Milky Way had a closer, brighter view of neighbouring galaxies. Back then the night was denser with light. Now most of those glimmers have faded beyond visibility, their light diluted by distance and time. You live in a more spacious, lonelier cosmos than your ancestors did, not metaphorically, but literally. Scientists still argue whether light might carry subtle information about what came before the Big Bang. Some suspect that the faintest background patterns, tiny anisotropies in the cosmic microwave background, might hold fingerprints of an earlier universe or before encoded in afterglow. But the data are slippery. Every attempt to read them is like trying to reconstruct a novel from ashes. Still, we keep trying because it's what humans do. We stare into noise and hope it speaks. You drift further with the photon. It grazes the halo of a galaxy cluster where gravity bends light like glass. Einstein predicted this too, gravitational lensing. Space curves around mass, and light obediently follows the curve. For a moment you see how even a straight line in the universe is a kind of illusion. Everything bends, everything leans towards something else. It's a quiet comfort really, even light can't help but be swayed. A soft joke drifts through your head. Light travels billions of years just to end up on your bedsheet at 3 a.m. reflected from your phone screen as you doom scroll. If photons could sigh, they probably would. They leave quasars just to illuminate cat videos. Cosmic irony at its finest. You return to the cosmic view. Somewhere out there, another observer on another world, if such beings exist, sees the same photon, but from a different angle, a different moment. For them, it's part of their own night sky story. Expansion ensures you'll never meet. Relativity ensures your now and their now may never align. The universe doesn't synchronize clocks. It lets everyone dream on their own timeline. The oldest light, the cosmic microwave background, comes from a time when the universe was only 380,000 years old, a baby glowing in infrared. That's the limit of what you can see, a wall of fog beyond which the cosmos was opaque. Before that light couldn't travel freely, the soup of charged particles kept scattering it. When atoms first formed and the fog lifted, the universe finally became transparent. You're looking at that moment every time you tune an old radio between stations. The hiss you hear. About 1% of that static is the afterglow of creation. It's oddly grounding to think that something so vast hums right inside your kitchen appliance. The universe leaves breadcrumbs everywhere. Microwave radiation in your Wi-Fi, cosmic rays in your DNA, starlight in your reflection. You're not outside of it. You're woven through it. The photon finally lands on your eye, your pillow, your thought. Its story ends absorbed and turned into a nerve impulse. 13 billion years of travel concluded in a single blink. Expansion continues, unconcerned, unhurried. The photon is gone, but its echo lives as warmth in your skin, as the gentle reminder that everything in motion keeps moving even when you stop watching. You let that idea settle. Light never looks back, because looking back would mean slowing down. And the universe, like you, is not built for reverse. It just keeps going quietly, beautifully, and a little bit absurdly forever, chasing the edge of its own horizon. You float with the memory of that photon still cooling behind your eyes, and now you start to wonder if all this light has been running since the beginning. What exactly was the starting line? The truth is, there wasn't one in the way most people imagine. There was no fireball exploding into space. There was space itself expanding all at once everywhere. No center, no edge, no place to stand outside of it. The Big Bang wasn't a bang at all. It was a beginning that never ended. You're still inside it, still part of its first exhale. Imagine the entire universe as a balloon that inflates evenly. Every point on the surface moves away from every other point, yet no point is the center. That's how expansion works. When you think of the Big Bang, don't picture debris flying from an explosion. Picture space itself stretching, carrying galaxies like dust motes in sunlight. You're not watching it happen, you're in it, suspended in motion. The mainstream fact-tonight scientists estimate that 13.8 billion years have passed since this expansion began. That number comes from triangulating multiple cosmic clues, the redshift of galaxies, the cosmic microwave background, and even radioactive decay patterns in ancient stars. It's an astonishingly consistent age across independent measurements. That means the universe is old enough for everything you see, stars, planets, people to have unfolded slowly, not from chaos but from patient physics. And here's the quirky counterpart. The Big Bang Theory didn't start as cosmic poetry, it started as a theological argument. In the 1920s, Georges Lemaitre, a Belgian priest and physicist, proposed that the universe began as a primeval atom. He meant it metaphorically, a seed of creation from which everything expanded. His idea was ridiculed by some, including Einstein, who said your math is fine, but your physics is abominable. Later, when the evidence stacked up, Einstein quietly took it back. The universe, it turns out, doesn't care whether its truths sound holy or heretical. Scientists still argue whether before the Big Bang even makes sense as a phrase. Time itself might have begun with that expansion. In quantum gravity models, asking what happened before is like asking what's north of the North Pole. The coordinate system breaks down, and yet theoretical physicists, being human, can't resist peeking past the curtain. They debate quantum tunneling models, eternal inflation, and cyclical universes where expansion and contraction alternate forever. It's a cosmic version of Are We There, yet shouted across eons. You picture that first moment, if moment even applies. Temperatures so high that matter couldn't exist, only pure energy, then quarks and leptons, then hydrogen, helium, and the seeds of everything else. Expansion wasn't calm, it was frantic, 1 trillion degrees of impatience. Yet out of that chaos came order, gravity pulling matter into clouds, stars igniting galaxies, spinning up like cosmic pinwheels. Every carbon atom in your body was forged in that sequence, recycled through stars that died long before Earth was cool enough to walk on. You're literally made of the universe's ash, its after-party confetti. A little joke for your insomnia cosmologists sometimes say we live in a reheated leftover universe. If the cosmos were a microwave dinner, we're in the crusty edges that cooled unevenly but somehow still taste okay. As you drift, you realize expansion isn't just about distance, it's about time itself stretching. The further you look, the younger the universe you see. Faraway galaxies are baby pictures caught in light. The cosmos you inhabit is like a hall of mirrors reflecting its own childhood at the edges. You can't see beyond that because the universe in its early years was too dense for light to escape. There's something tender in that our horizon is a kind of cosmic privacy screen protecting the universe's first moments from our gaze. Now think about this. If everything's expanding, are you expanding too? The atoms in your body sit on the same stretching fabric, but they don't move apart because other forces, electromagnetic, nuclear, gravitational, keep them bound. Expansion only wins where nothing else can hold on. Between you and your coffee cup, no effect. Between galaxies millions of light years apart. The stretching is relentless. It's like the universe politely respects your personal space, but completely disregards galactic boundaries. Scientists still debate the precise rate of this expansion, the Hubble constant, and we'll get to that later. But for now, imagine that invisible tide beneath you pushing the distant galaxies outward. Not away from you specifically, but away from each other. Each one feels itself at the center just as you do. The universe grants everyone the illusion of centrality, a humbling gift wrapped in mathematics. If you could see the cosmic timeline as a single painting, the colors would fade from brilliant blue-white heat to gentle red cold calm. You live near the edge of that painting in a cooler, slower part of the story. But the expansion never stopped. It's still writing more canvas under your feet. The space between galaxies grows, but so does the silence between moments. Time itself may be slowing its rhythm, diluted by the stretching stage it performs on, and maybe that's why you feel something familiar in the universe's behavior. The way it grows but never returns. The way it carries its past as light, always moving forward but never forgetting. The way even its beginnings are unreachable, tucked behind horizons of memory. You and the cosmos share that trait, both expanding through time, both unable to look back without distortion. You breathe out. For a second, it feels like you can hear the universe doing the same, exhaling stars, galaxies, radiation, all drifting into the long night. There's no center, no edge, just an endless continuation. A breath that began once and never stopped. You keep drifting, carried by that endless breath, until you begin to notice a faint static in the dark, like the hiss of an untuned radio. It's everywhere, no matter which direction you turn. Not loud, not dramatic, just a steady whisper woven into the silence. That whisper is older than any star you can see. It's what's left of the first light the universe ever released, the cosmic microwave background. You could call it the universe's baby picture, though it's more like a thermal selfie taken when it was about 380,000 years old, still an infant, still glowing from the heat of its birth. Back then, the cosmos was a dense fog of charged particles. Photons couldn't travel far without bumping into electrons and bouncing off again. But as the universe expanded, it cooled, and that fog finally cleared. At that instant, light was free to roam, and it's been traveling ever since, stretching, with the universe fading into microwaves we can still detect today. The mainstream fact: in 1965, Arno Penzias and Robert Wilson accidentally discovered this afterglow while working on a radio antenna in New Jersey. They were trying to remove what they thought was interference, maybe pigeon droppings in the horn of the antenna, but no matter what they cleaned, the noise remained. It turned out to be the leftover heat from the Big Bang itself, the sound of the cosmos clearing its throat. They won the Nobel Prize, the pigeons did not, and here's the quirky bit: the cosmic background isn't perfectly uniform. It has tiny temperature ripples, 1 part in 100,000, that mark where matter was slightly denser. Those ripples were the seeds of everything galaxies stars you. Without those small imperfections, the universe would have been a featureless soup forever. You're here because the early universe wasn't perfectly smooth. Perfection, it seems, makes for boring physics. Scientists still argue whether those first fluctuations came purely from quantum randomness or from a brief wild phase called inflation. Some claim that in the universe's first fraction of a second, space expanded faster than the speed of light itself, stretching tiny quantum jitters into vast cosmic structures. Others suggest different mechanisms, exotic fields, or cyclical pulses of creation. The debate continues partly because no telescope can see that far back, and partly because physicists love a good mystery to ruin their sleep schedules. Imagine yourself floating through that ancient radiation, a soft bath of microwaves filling all of space every cubic meter, humming with 400 photons. Their average wavelength is about 2 millimeters, but to your skin they're harmless, just a whisper of heat. If you could see them, the entire sky would glow faintly in every direction, the same gentle light that once washed across newborn hydrogen. You wouldn't need stars. The cosmos itself would be softly lit, a kind of eternal twilight. You reach out and the background wraps around you like an old blanket. It feels oddly personal. These photons have been travelling for nearly 14 billion years, bouncing off, nothing slowed by nothing untouched until now. They tell a story written in temperature variations, the warm spots that became clusters of galaxies, the cool spots that became the voids between them. From those faint freckles of heat, everything recognisable was sculpted. You smile at the thought all of existence is basically a slightly uneven cooling process. You the galaxies, even the concept of here just localised a symmetry in an otherwise perfect chill. A light joke for the night cosmologists once joked that the universe started as a hot mess that cooled off enough to host people who argue about it. In fairness, they're still arguing. If you were to translate the cosmic background into sound, it would be a deep, steady hum. Not like music, more like the echo of an ocean shell. Some researchers have actually sonified the data. The temperature variations become notes. The early universe plays its own lullaby. You could fall asleep to it, in fact you sort of already do. The faint hiss between radio stations, the gentle static in your electronics, they all contain a trace of that ancient note. But even the cosmic background isn't static forever. As the universe expands, those microwaves stretch to longer wavelengths, becoming colder, dimmer, harder to detect. In trillions of years, there'll be radio waves so long they might not interact with anything at all. The afterglow will fade into silence. But for now, you're lucky you live in the brief middle act where the universe is still audible. Scientists still debate one last haunting detail, whether there might be a shadow in that background, a faint circular mark left by another universe brushing against ours before inflation pulled them apart. Some cosmologists think they've seen hints of such imprints, others say it's noise. Either way, the idea lingers that the cosmos might have cousins, each carrying its own background whisper. You tilt your head as if listening harder might help. But the signal doesn't speak in words, it speaks in temperature and ratios, in the slight unevenness of perfection. And somehow that feels more honest than any language could be. As you drift, the static becomes softer, more rhythmic. You start to hear your own breath echo it. Inhale, the universe expands. Exhale, it cools a little more. Somewhere in that symmetry you realise the cosmos doesn't need to look back because it left a perfect memory of its youth everywhere. It's not gone, it's just redshifted. You linger in that afterglow until a subtle tension tugs at your attention. Gravity, the great skeptic of the universe, quietly clearing its throat. For all the expansion and lightness, there's always been a counterforce trying to pull everything back together. Gravity doesn't shout. It whispers slowly over eons, patient as frost building on glass. In the beginning, the universe was a balancing act between two desires to spread out and to collapse. Matter wanted to clump, space wanted to stretch. For a long time, gravity seemed destined to win. Galaxies formed, stars ignited, clusters grew, all from the irresistible urge of particles to huddle. Every planet you've ever loved is a victory of gravity over emptiness. Here's your mainstream fact: every object with mass attracts every other, and that attraction never truly stops. The force falls off with the square of distance, but it never hits zero. That means that in principle, every atom in your body feels the pull of every star in the universe. You're in the most literal sense connected to everything. Romantic, yes. Inconvenient, also yes. Now, the quirky bit scientists once imagined that gravity might eventually halt expansion and reverse it a big crunch. In the 1970s and 80s, it was almost gospel that the universe would one day slow, then contract, collapsing back into the same singular density it came from. There were cosmologists who toasted to it, cheers to the ultimate recycling program. But the universe, being the cosmic trickster, it has refused to cooperate. In the late 1990s, two teams studying distant supernovae discovered something that changed everything. Those exploding stars were dimmer than expected. That meant they were farther away than models predicted. Instead of slowing, the expansion was accelerating. The force of gravity was losing the cosmic tug-of-war. Something unknown was pushing the universe apart faster and faster. Scientists still argue whether that something is truly constant or slowly evolving. They call it dark energy not because it's dark, but because it's a mystery wrapped in an equation. It makes up about 68% of the total energy in the cosmos, yet we have no clue what it is. You can almost hear Einstein muttering, "Told you so," from beyond the grave. If you could see gravity as a character, it would be a stubborn old craftsman kneading galaxies into spirals, binding stars into families, building planets with slow devotion. Dark energy, by contrast, is the minimalist artist's silent invisible stretching the canvas itself. They coexist uneasily like roommates who never speak but somehow keep paying the rent. Scientists still debate one haunting possibility: maybe gravity itself changes at cosmic scales. Some modified gravity theories propose that what we call dark energy is just the weakness of gravity over enormous distances. Others argue it's a property of the vacuum-empty space that isn't truly empty, but filled with quantum jitters that push outward. Whatever the cause, the effect is real. Galaxies are accelerating away, as if the universe suddenly remembered a long-forgotten appointment and can't stay. A little cosmic humor: if gravity were a person, it would definitely have trust issues. It spends billions of years pulling things close only for dark energy to whisper let go. You drift between these two forces. Around you, galaxy clusters still cling together, gravity's last loyal followers, but beyond them the expansion wins. Even light itself struggles, its path stretched, its wavelength lengthened until its message fades. The balance that once shaped everything is slipping. Yet paradoxically, gravity remains the reason you can exist to notice any of this. Without it, no stars, no carbon, no warmth. It's the universe's paradox. The same force that keeps your feet on the ground is trying futilely to hold the cosmos together. You could almost feel sorry for it, an eternal effort destined to lose slowly. And maybe that's why the night sky feels so poignant. Every gleam you see is gravity's signature light, born from collapse, from atoms crushed close enough to burn. You're surrounded by evidence of the losing side's brilliance. Gravity's defeats are beautiful. The scientists who model this balance use words like curvature and density parameter, but the emotional truth is simpler. The universe expands not because something exploded, but because nothing can fully contain everything it holds. Space keeps making room for its own stories. You think about your own gravity, the pull of memories of people of home, and how life too is a balance between holding on and letting go. Maybe expansion and gravity aren't opposites at all. Maybe they're how existence breathes. A soft laugh escapes you, the kind that comes when the paradox finally makes sense. Gravity may be losing the cosmic contest, but it already won the intimate one. It keeps your heartbeat anchored even as galaxies race away. The universe expands, but you don't float off your chair. Somehow that feels like mercy. And in that quiet mercy, you realize gravity isn't trying to stop expansion anymore. It's simply teaching you the art of resistance, how to stay whole while everything else moves outward. You feel the tug of gravity fade into the background, and what replaces it isn't motion, it's fabric. Not a metaphorical one, but the literal geometry of the universe, space-time itself. You picture it not as emptiness, but as something supple, elastic, like dough rising in a cosmic oven. That's not far from what Einstein meant. Space isn't just where things happen. It is a thing, a field that bends, stretches and curves in response to energy. You're sitting on it right now, though you'll never feel it under your skin. The mainstream fact tonight, Einstein's general relativity, tells us that gravity isn't a force in the old Newtonian sense. It's the curvature of space-time. Massive objects deform that geometry and smaller ones follow the curves. Earth orbits the sun not because it's being pulled, but because it's gliding along the warped shape of the space around it, like a marble rolling on a stretched sheet. Now here's the quirky twist: the universe doesn't expand into anything. There's no outer void swallowing it. Space itself is stretching everywhere, even between galaxies that aren't moving through space but being carried with it. Imagine two raisins in bread dough, they're not travelling. The dough between them is rising. That's expansion. The dough is space-time. You float through it now, trying to sense the stretch. Between you and the nearest galaxy cluster, space has added millions of light years since the universe began. You wouldn't notice, of course. It's perfectly uniform, like air filling every crevice. There's no wind of expansion, no sensation of drift. The galaxies aren't propelling themselves away, the metric defining their distance is literally changing. Scientists still argue over how to picture this properly. Some prefer the balloon analogy, others hate it because it implies an outside. But all agree on this: the universe doesn't need edges to expand. Expansion is what happens when the distance between unbound points increases over time, regardless of whether there's a beyond. It's not that the universe grows into something, it's that the concept of distance itself changes. Space-time writes bigger numbers in its own notebook. If you could somehow stand outside the cosmos, which you can't, you wouldn't see a fireball spreading. You'd see a boundaryless continuum, every part growing more diffuse. Inside every observer, wherever they are, feels like the center. That's why every galaxy sees every other galaxy receding. It's a symmetrical illusion built right into the physics. Everyone gets to feel special, which is probably the most democratic thing the universe ever did. A small joke drifts through your head. If the universe were a loaf of bread, it's the only one that bakes itself from the inside and never runs out of yeast. You look closer and you notice that not everything follows the expansion. Galaxies hold themselves together. Solar systems ignore it entirely. Even the atoms in your hand don't budge. Local forces overpower cosmic ones. Expansion is a phenomenon that lives between the islands of gravity's empire. You could call it the tide that fills the gaps between galaxies but leaves the shores intact. Scientists still debate how to describe expansion at very small scales. Mathematically, the equations apply everywhere, but physically bound systems don't care. That's why the Andromeda galaxy is actually moving toward as gravity overrules expansion locally. Cosmic growth is patient. It respects gravity's temporary reign in small kingdoms like ours. You drift farther, and the fabric itself begins to shimmer. Imagine space as a grid. Between the lines, something invisible hums the vacuum energy. Quantum fields seethe even where nothing exists. It's this energy that many physicists suspect might be dark energy, an intrinsic pressure of space itself. When you remove everything else, space doesn't become zero. It becomes restless. That restlessness pushes outward, stretching the grid. You exhale slowly, feeling an odd empathy with the cosmos. Sometimes the emptier you feel, the more room there is to grow. The thing about this stretching is that it has no preferred direction. Every part of space expands uniformly, like an orchestra, where every instrument increases its pitch in perfect synchronization. There's no center note, just a rising harmony. If you could translate expansion into sound, it would be a deep, slow crescendo, inaudible, but steady. A hum beneath existence. You realize the air around you, the space between the atoms in your lungs, even the distance between your thoughts are all part of that same elastic continuum. You don't float in the universe, you're woven into it. You're not the raisin, you're the dough. A light chuckle breaks the stillness. Imagine trying to explain that at a dinner party. I'm expanding. No, not like that. You start to see the elegance of it all the way. Galaxies drift apart, not because they're lonely, but because expansion creates space for solitude. There's something tender in that. The cosmos grows by giving everyone room. But it's not endless chaos. On small scales, patterns emerge, filaments of galaxies stretched along invisible threads, cosmic voids yawning in between. The geometry of expansion builds structure and emptiness in equal measure, like a living fractal that never stops breathing. And as you watch it, something inside you slows. The concept of distance feels less like a measure and more like a memory. The farther light travels, the older it becomes. The farther you look, the deeper you reach into time. The expanding fabric doesn't just shape where things are, it shapes when they are. You're adrift in a place that grows in every direction, even the direction of the past. And you finally understand expansion isn't something happening outside of you, it's happening to you, through you, within you. Every breath adds a microscopic ripple to the fabric of the same cosmos that stretches the stars apart. Somehow that makes you feel less small, not an observer, but a participant in the universe's quiet art of becoming. The fabric stretches quietly beneath you, and suddenly the colors begin to drift. What was once white starlight fades toward amber, then crimson, until everything distant glows in a tired red sigh. It's as if the universe itself is blushing from exhaustion. This is redshift, the light's version of jet lag. Every photon that crosses an expanding space gets its wavelength pulled, just like a note that drops pitch as the instrument lengthens. The farther it travels, the redder it becomes. And because redshift grows with distance, you can look at a galaxy's spectrum and read its speed like a cosmic speedometer. The light literally tells you how fast it's leaving you behind. The mainstream, fact Edwin Hubble and Milton Humason, first measured this effect in the 1920s. They discovered that distant galaxies' spectral lines, fingerprints of elements like hydrogen, were consistently shifted toward the red end of the spectrum. The farther away the galaxy, the greater the shift. This wasn't random motion. It was systematic. The universe, they realized, was expanding everywhere at once. Hubble's graph changed everything. The quirky tidbit. Some astronomers originally thought the redshift might be caused by tired light. that photons simply lost energy over long travels like marathon runners slowing down. The idea lingered for decades until careful tests showed that light doesn't age that way. It's not fatigue, it's geometry. The photons aren't slowing, the space they move through is stretching. It's the treadmill itself that's speeding up. You watch one of those galaxies in your mind's eye, a bright spiral shimmering at the edge of visibility. The light you see left when Earth's first multicellular life was just figuring out how to wiggle. That galaxy might not even look the same anymore. It's already moved millions of light years farther away, its light stretched even longer. You're catching a memory that keeps aging as you stare at it. Scientists still argue whether all redshifts are purely cosmological. Some rare galaxies exhibit anomalous shifts, spectral fingerprints, that don't line up neatly with distance. Most likely they're quirks of local motion or measurement. Still, the tiny uncertainties remind us that even cosmic laws leave room for mystery. You float deeper into that scarlet ocean. Everywhere wavelengths stretch, colors fade, and silence thickens. The night sky, which seems timeless from Earth, is actually a time machine. Every red glimmer you see is a goodbye wave. The universe isn't dark because it's empty, it's dark because light takes time, and time is always running late. A gentle joke, astronomers like to say they're not studying space, they're doing archaeology at the speed of light. You could say telescopes are just very patient shovels. The redshift carries a subtle melancholy. The farther you look, the younger the cosmos becomes, but also the lonelier. Galaxies beyond a certain distance recede faster than light due to expansion. Their photons stretched endlessly will never reach us. They vanish not into black holes, but into forgetfulness, the unreachable part of the universe we call the cosmic horizon. That boundary grows every second, swallowing the familiar stars one by one. Still, there's beauty in that loss. Redshift is proof that time moves forward. Every stretched wave is the universe's heartbeat recorded in color. When astronomers map those colors, they're listening to the rhythm of creation itself. You try to imagine what color even means at these scales. There's no human eye to see the deep infrared of galaxies racing away. The light has been diluted into wavelengths meters long. Ghost colors invisible but real. Some detectors aboard satellites like JWST can still catch them, turning those whispers into images. You've probably seen one, those hazy webs of crimson galaxies glowing against black velvet. Each pixel is ancient starlight taking one last bow before fading into silence. Scientists still debate the exact limits of what we can see. How far is too far? Where does the observable end? It depends not on space but on time. Light from beyond, 46 billion light years away, will never reach us, not because it's slow, but because the fabric between us grows faster than the light can cross it. The universe expands and visibility itself has an expiration date. You think about that for a moment, how every look backward is also a kind of loss. The more you learn, the more the present dissolves into past, but it's also a gift. You're seeing evidence of motion too vast to comprehend, yet gentle enough to paint your night sky. A tiny pulse of humor sneaks in. If the cosmos had an Instagram, every photo would be a throwback. TBT me 10 billion years younger. You drift along a beam of light as it fades through crimson into infrared, its energy spent, but its story intact. The color doesn't die, it just moves beyond your senses. The photon still travels unbothered by your limits. Somewhere out there in some future far beyond stars, it will still be stretching, chasing the edge of time. And you're watching it happen from inside the same expansion. The blood in your veins carries the same electromagnetic signature, the same physics, the same quiet inevitability. You're redshifted too in your own way, stretched by time, thinned by distance from your beginnings, yet still radiant. The galaxies recede, the light grows faint, the universe hums its ancient tune forward, always forward. You can almost hear it, a frequency so low it becomes silence, and as you listen, something in you relaxes. Maybe this is what peace feels like in cosmic language motion, without effort, departure, without grief. You drift a little farther still, wrapped in that reddish haze, when suddenly you sense an invisible hand at work. Not the tug of gravity this time, but its opposite. The galaxies you passed a moment ago are accelerating away faster and faster, as though something unseen is pushing them outward. It's not just expansion anymore, it's propulsion without engines, acceleration without cause. Welcome to the era of dark energy. No one asked for it, and no one truly understands it. The term is a placeholder, a confession disguised as confidence. Scientists named it so they could at least talk about it without having to shrug every few seconds. It's a kind of energy woven into empty space, not matter, not radiation, but something else entirely, something that doesn't dilute as the universe expands. While everything else thins out, dark energy stays the same, like a stubborn tenant who refuses to move out no matter how big the house gets. The mainstream fact tonight: about 68% of the total energy content of the universe is dark energy. Dark matter makes up another 27%. The rest, stars, planets, gas, all the visible stuff, amounts to less than 5%. You, your entire history, and every shining galaxy in the sky belong to that tiny glittering fraction. The rest of reality is invisible and inscrutable. You're living in a universe mostly made of we don't know. Now for the quirky bit: when astronomers first discovered the accelerating expansion in 1998, some thought the data must be wrong. Two separate research teams, both measuring distant supernovae, found the same shocking thing. The galaxies weren't just coasting apart, they were speeding up. Someone even joked, maybe the universe just hit the cosmic gas pedal. That's not far from the truth, except no one knows what foot is pressing it. Scientists still argue over the true nature of dark energy. Is it Einstein's cosmological constant, a fixed property of space itself, or something dynamic like a field that changes over time? There are theories of quintessence, phantom energy, even modified gravity, each promising a different flavor of cosmic weirdness. Observations so far fit the simple model of constant vacuum energy, but new data occasionally hint at something stranger, something that evolves. Cosmologists keep measuring, refining, doubting a slow waltz between humility and math. Imagine dark energy as a gentle pressure filling the void. It doesn't push galaxies the way wind pushes sails. It stretches the space between them, and the galaxies simply go along for the ride. Over cosmic time, that stretching becomes domination. Gravity grows weaker as matter spreads out, while dark energy keeps the same strength. Eventually it wins completely. The great structures of the universe, clusters, superclusters, webs will drift apart until no light can cross the gulfs between them. You pause on that thought, an ultimate loneliness written into the laws of physics. The further the expansion accelerates, the more isolated every island of matter becomes. In trillions of years, any future observer in some faraway galaxy will look into a black sky and see nothing. No cosmic background, no neighboring galaxies, no memory of the Big Bang. Their universe will appear static, empty, eternal, the ultimate cosmic prank. A small, darkly funny thought: the universe is slowly deleting its browser history, and we just happen to live before the final "Are you sure?" prompt. But here's the curious comfort: even in this apparent bleakness, there's beauty. The acceleration means the cosmos has built-in renewal. It can never truly stagnate. Space itself is creative, always making room for more of itself. The expansion may separate worlds, but it also ensures motion novelty, the constant rewriting of the sky. Some fringe physicists have speculated that dark energy might one day change sign, flip from repulsive to attractive. If that ever happens, the expansion could reverse into a big crunch, collapsing everything back into fire. Others fear a big rip, where the acceleration becomes so extreme it tears galaxies, stars, and even atoms apart. And a few dream of cyclic models where each universe ends only to seed the next. No one knows. The only consensus is that we live in the middle of something vast and mysterious, and the equations hum like lullabies that never quite rhyme. You picture dark energy as a kind of cosmic background music, inaudible, steady everywhere. If gravity is the baseline, dark energy is the endless rising tone, the swell that keeps the melody from ever resolving. You can't feel it locally, it's too diffuse, too patient, but over billions of years its influence reshapes everything. You think of it the way you think of time, invisible but unstoppable, gentle yet absolute. Maybe dark energy isn't a thing at all. Maybe it's what happens when existence itself relaxes, when the universe exhales and refuses to inhale again. You look around, every star you see tonight is quietly participating in that expansion, sliding imperceptibly, farther away, while burning its own finite fuel. You too are carried by it cell by cell, breath by breath, part of the same slow acceleration. You'll never feel it, but it's there in every second that stretches longer than the last, in every silence that hums just slightly deeper than before. And maybe as you drift further into that idea, you realize something soft and strange: the universe doesn't need to know why it expands. It just does. Growth without motive. movement without goal. It's not escaping something, it's becoming more of itself. Somewhere far out another galaxy slips beyond the edge of sight. Its light will never reach you, but you don't mind. You wave anyway, a small human gesture toward a cosmic mystery. The gesture vanishes, absorbed by dark energy itself, the universe's quiet way of saying I remember you even when I move on. You keep floating, carried by that silent outward rush, and as the light fades to invisible hues, another ghostly figure rises from history, a mathematician with kind eyes and a lifetime's worth of second thoughts. Albert Einstein, reluctant father of the universe's expansion, steps into the picture. You already know his equations bent space and time into one flexible geometry, but what's less known is how much he resisted their own implications. When Einstein first finished his field equations in 1915, they predicted a dynamic universe, one that couldn't sit still. Either it would expand or it would contract. Yet in 1917, when he applied the math to the cosmos, the very idea horrified him. Everything astronomers saw then, the stars, the Milky Way, suggested a static eternal heaven. Expansion seemed absurd, so Einstein did what all great scientists secretly do when the math misbehaves: he patched it. He added an extra term to his equations, a kind of cosmic anti-gravity that balanced attraction with repulsion. He called it the cosmological constant, or L lambda. Its job was to hold the universe in place like wedging a chair under a door to stop it from swinging open. The trick worked perfectly on paper. Reality, however, was already laughing. The mainstream fact, once Edwin Hubble published his data in 1929, showing galaxies flying apart, Einstein dropped the constant, calling it my greatest blunder. He assumed the universe really was expanding, and that L had just been a mathematical bandage. He couldn't have guessed that decades later, physicists would dig that same constant out of the trash and find it describing dark energy almost perfectly. And the quirky detail, according to eyewitnesses, when Einstein visited Hubble's observatory in California and looked through the telescope himself, he muttered, "Well, I guess that's that." You can imagine him shrugging, the most polite oops in history. Scientists still argue whether L is truly constant or just a snapshot of something deeper, a shifting vacuum energy, a field that evolves, or a numerical illusion caused by our incomplete understanding of gravity. The beauty of science is that it doesn't hide its doubts, it wears them like badges. The cosmological constant remains the most precise, yet least understood quantity, in physics accurate to over 120 decimal places and utterly mysterious. You picture Einstein's equations glowing faintly in the dark, etched across the sky. Lambda, G, was ha, anod PG, Nostistiam, organ plostus TG10. They look intimidating, but the story they tell is simple matter and energy. Tell space how to curve and curved, space tells matter how to move. L adds one more line to that conversation, a whisper from the vacuum itself saying expand. You drift through that vacuum now, trying to imagine what it means for nothing to have energy. Quantum physics insists that empty space isn't empty at all. It seethes with virtual particles appearing and disappearing faster than you can blink. On average, they balance out, but not perfectly. That tiny leftover energy could be what drives cosmic acceleration, the universe expanding on the interest payments of nothing. A quiet laugh rises in you, the ultimate startup creation with zero capital. And yet it's too neat. The vacuum energy predicted by quantum theory is far, far too large, 1/120 times stronger than the observed dark energy density. It's been called the worst theoretical prediction in the history of physics. Somehow the universe cancels almost all of it, leaving a whisper where there should be a scream. Scientists still argue how that miracle happens. Coincidence, fine-tuning. A clue to new physics nobody knows. You imagine Einstein hearing that number. He'd probably adjust his glasses, sigh, and say something like, perhaps God has more subtlety than we assume. Whether or not he believed in any deity, he believed in elegance. For him, the equations had to sing. And maybe they still do, well, it might just be the soft background note of the universe's song. You drift beside that symbol, now L, floating like a candle flame in the void. It doesn't move, doesn't flicker, just is. A reminder that sometimes the smallest term changes everything. In the quiet, you think about your own constants, the tiny invisible forces that keep your life from unraveling. Gravity holds galaxies. A few quiet truths hold you. Both are unseen until they fail, and then you realize how much they mattered. A small joke to lighten the darkness: imagine if Einstein had social media. Just invented a cosmological constant. Instant stability. Universe hack. 2 posts later, never mind. Deleting L. Oops. You keep drifting the equations, fading into starlight. Einstein's blunder wasn't a mistake, it was a prophecy. He'd invented the very concept that would one day explain dark energy, half a century before anyone knew it existed. And as you move with the expansion he once resisted, you realize something gentle: every mistake, even a cosmic one, is just a future truth wearing the wrong costume. The universe doesn't punish errors, it evolves them. L, once a sign of stubbornness, became a symbol of persistence. Proof that even wrong ideas can curve space-time beautifully. Somewhere far off, galaxies keep receding, and Einstein's symbol hums in the fabric like a hidden bass note. The universe's way of saying, "Thank you, Albert, I've got it from here." You keep floating, and suddenly the universe feels strangely geometric, not emotional or poetic, but mathematical, like the inside of a quiet cathedral built from pure numbers. The stars fade into a grid, the galaxies into points, and you begin to wonder, is the cosmos curved flat or something in between? It's not just idle curiosity. The shape of the universe decides its fate. Geometry on this scale is destiny. The mainstream fact modern cosmology says the universe is remarkably flat, meaning if you could draw an enormous triangle using 3 beams of light across billions of light years, its angles would add up to exactly 180 degrees. No cosmic bulge, no grand concavity. That's what data from the cosmic microwave background tells us space doesn't curve much at all, at least within the part we can see. But that word "within the part we can see" hides the real uncertainty. The universe could be gently curved on scales beyond observation, bending subtly, like a sphere too vast to notice, or rippling like the skin of an ocean. Scientists still argue about that curvature. Even a tiny positive or negative deviation could hint at infinite possibilities: a universe that loops back on itself, or one that extends endlessly flat as a mathematical sheet. The quirky part, if the universe is closed, curved back onto itself like a 4-dimensional sphere, you could in theory travel far enough in one direction and end up where you started, just like walking around the Earth. Only it might take longer than the lifetime of stars. Some cosmologists have even proposed searching for repeating patterns in the cosmic microwave background echoes of light that have wrapped all the way around the universe. So far, no luck. But the idea that space could fold like origami never stops being deliciously weird. You picture yourself gliding along one of those light beams, drawing your side of the cosmic triangle. The distances are absurd: 1 billion light-years between corners, your ruler made of photons. The space you travel through is smooth without friction, but not without structure. Here and there, gravity dimples the grid galaxy clusters, bending space ever so slightly. You can almost see it flex like glass under pressure. Scientists describe this geometry with a parameter called OK omega sub k, the curvature density. If OK equals 0, the universe is flat. Positive means closed like a sphere, negative open like a saddle. Current measurements put OK so close to 0 that it's almost suspicious. It's as if the universe spent all its energy balancing on a knife edge of perfection. Why should it be so flat inflation that explosive expansion in the first fraction of a second is the leading suspect? It stretched out any initial wrinkles, flattening space the way blowing up a balloon smooths its surface. It's a cosmic ironing job done at unimaginable speed. You drift along, running your mind over that invisible surface. It feels smooth, almost too smooth. The early universe could have been chaotic, but inflation pressed it into calm. You can't help smiling, even the universe needed a little self-care in its youth. A light joke passes through you. If the cosmos really is flat, then technically you're living in a universe with excellent posture. Scientists still debate whether this flatness means the universe will expand forever, or eventually curve back on itself. Geometry sets the stage, but the actors dark energy, dark matter decide the ending. Even a flat universe can accelerate into oblivion. Flat doesn't mean safe, it just means balanced for now. If the universe were curved positively, gravity could one day overcome dark energy, slowing expansion until everything collapses into a final fireball, the big crunch. If negatively, expansion would continue, eternally thinning everything into nothingness, the big chill. But with dark energy at the helm, the most likely fate seems stranger still. eternal acceleration leading perhaps to a big rip where even atoms are eventually torn apart. You realize geometry isn't cold math, it's philosophy made physical. A flat universe is one that walks the narrow path between rebirth and decay, neither folding back nor breaking apart a razor's edge of existence. And somehow that mirrors you more than you'd like to admit. The space inside you between heartbeats, between thoughts, feels similarly balanced. You live between memory and possibility, between what collapses inward and what expands beyond reach. The universe, it seems, practices mindfulness on a cosmic scale. You try to visualize what it means for space to be flat, but visualization fails. There's no outside to step into, no shape you can hold. It's not a surface floating in something larger, it's the metric itself, the way distance is measured. When cosmologists say flat, they mean parallel lines never meet. Space simply continues unbending, unhurried, infinite in all directions. Still, the idea of curvature lingers because even flat space is curved locally. Every mass bends it. Every planet adds a wrinkle. Every star is a tiny dimple in an otherwise calm sea. The universe then is a quilt, vast, nearly flat overall, but stitched with billions of tiny pockets of curvature, each one a home for light, matter, and story. And you, a small ripple on one of those patches, are part of that pattern. You're the universe noticing its own geometry, marveling that straight lines in practice always bend a little. As you glide onward, you leave behind the glowing equations and float into a softer realization it doesn't matter if the universe is flat open or closed. What matters is that it's continuing. Every shape, every destiny, every theory points to motion, an unbroken expanding act of creation. Somewhere ahead, space hums, still making room for more of itself. And you, drifting with it, feel the quiet reassurance that no matter the curvature, existence never quite runs out of room to grow. You've been drifting for what feels like hours, and suddenly a question flickers across your mind like a mischievous comet. If nothing can go faster than light, how can the universe itself outrun it? That's the trick. Light may have the cosmic speed limit, but space, being the lawmaker, writes its own loopholes. Mainstream fact first, according to relativity, no object in space can move through space faster than light, but nothing forbids space itself from expanding faster than that limit. During cosmic inflation, the universe's scale factor ballooned so quickly, the distant regions sped apart faster than photons could ever bridge them. Even today, galaxies more than about 14 billion parsecs away recede superluminally, not because they're racing through space, but because new space keeps forming between us. Light tries to chase them and never gains ground. You imagine it visually: two ants on a rubber band. You're the ant near the knot, your friend is near the other end. If the band stretches quickly enough, you'll never meet no matter how fast you crawl. Space expansion is that stretch, not a race. The quirky bit, some physicists like to call this the cosmic speed trap. It means there are galaxies whose light left billions of years ago and will never ever arrive, not even given infinite time. Yet we can still see some of them today, because we're catching photons released before the boundary sprinted beyond reach. It's like glimpsing a ship disappearing behind the horizon, the last flash of its sails preserved in light long after it's gone. You try to sense what faster than light even means here. There's no breeze, no acceleration. Locally, space is calm. Only when measured across unimaginable distances does the stretching become significant. The universe isn't tearing itself apart, it's quietly adding room. Scientists still argue how best to define recession velocity. Is it meaningful to say something moves faster than light when it's really the metric changing? The answer depends on coordinates, which in cosmology are philosophical as much as mathematical. Every observer gets their own version of now. There is no universal stopwatch ticking the same for all. Time itself stretches differently across that expanding stage. You take comfort in that relativity. It means the cosmos is flexible with perspective. Your edge of the universe might be someone else's backyard, just described in a different frame. To picture this, you turn your mind into a kind of planetarium. Points of light slide away, each anchored to its own bubble of space-time. The more distant they are, the faster they recede. Beyond a certain threshold, the Hubble radius light waves can never close the gap. They stretch endlessly, their energy diluted into whispers. Somewhere out there, entire galaxies are frozen in time, visible but unreachable, like postcards sent from a friend who has moved faster than goodbye. A soft joke surfaces: the universe is basically ghosting you at the speed of light. You keep texting with telescopes and it keeps leaving you unseen. But there's poetry in the paradox. Expansion faster than light doesn't break relativity. It defines its grandeur. The laws of physics aren't fences, they're choreography. They ensure that even when motion becomes impossible, connection through the relic light you still receive remains. You think about your own horizons. There are parts of your past receding so quickly you can't reach them again. Old versions of you friends who drifted out of orbit, moments that moved beyond communication. You can't overtake them. You can only watch their light fade gently into memory. Maybe cosmic expansion is just a scaled-up version of growing older. Still, not everything runs away. Gravity fights a local guerrilla war. Inside galaxies, it glues stars together. Inside atoms, electromagnetic forces keep electrons loyal. Those tiny pockets ignore the universe's accelerating ambition. Within them, causality still reigns. Clocks still tick. Normally breakfasts still burn if you leave the pan on too long. Expansion doesn't care about your kitchen. It's too grand for that. Scientists still debate whether distant superluminal regions can ever re-enter visibility if dark energy weakens. Some models suggest yes, a slow cosmic reconciliation. Others no, a permanent exile. Either way, the present universe contains both intimacy and estrangement written into its geometry. You glide onward, half scientist, half poet. The Milky Way hums beneath you, orbiting its own center like a calm heartbeat inside a storm of infinite scope. Somewhere beyond, galaxies flee faster than any farewell you could utter, yet the light they sent eons ago still strokes your eyes tonight. The paradox closes gently. You can't chase them, but you can receive them. Their photons arrive like messages bottled before the sea accelerated. Each one says, "We existed. We burned. We remember you remembering us." You smile because that's enough. The speed limit remains intact, yet communication continues slow, red, fading, but real. Maybe that's the universe's lesson. Separation isn't silence. Even when everything outruns everything else, something still reaches across the void. A flicker, a warmth, a trace. You let that thought settle in the back of your mind like afterglow. Space keeps stretching. Time keeps elongating. And you, a small passenger on a mid-sized planet, keep floating through the one loophole where impossibility and tenderness share the same velocity. The light around you dims into soft scattered constellations. One by one, the stars seem to huddle together in small glowing archipelagos, each surrounded by a sea of deep black. You're beginning to see the universe the way it really is, not as a continuous ocean of light, but as a collection of islands separated by ever-widening gulfs. Each of those islands is a galaxy bound together by gravity and insulated from the universe's grand expansion. Inside them, everything still works as it always has. Stars orbit, planets spin, dust becomes light. But between them, space itself stretches like pulled taffy, carrying them farther apart every second. Here's the mainstream fact: galaxies within gravitational clusters remain tied together, their mutual attraction strong enough to resist the cosmic pull. But beyond those clusters, expansion rules absolutely. Every million parsecs or so, the universe adds about 70 extra kilometers per second of recession velocity. That's the Hubble constant in action, a slow, relentless drift written into the fabric of existence. And here's the quirky bit: if you could mark every galaxy with a tiny flag in a few billion years, almost all of those flags would vanish from sight. Their light would fade beyond detectability as expansion redshifts it to wavelengths longer than the size of the observable universe itself. Future astronomers, if any remain, will look into the night and see only their own galaxy, floating alone in blackness. For them, the cosmic truth will seem to be that their island is the entire sea. You hover between these glowing metropolises, each one 100 billion suns strong. The Milky Way, your home, is one such city, not special, not central, just comfortably mid-sized. Nearby, the Andromeda galaxy looms faintly on a slow collision course that will take 4 billion years to resolve. Gravity, stubborn as ever, still keeps some neighbors close, even as expansion drives others away. Scientists still argue about how long local gravity can hold out. Simulations suggest that over trillions of years, only small gravitationally bound groups will remain. Clusters like Virgo or Coma will become lone, self-contained universes surrounded by absolute darkness. The grand cosmic web will dissolve into solitary nodes. Expansion doesn't destroy structure instantly. It erodes it through time. You drift closer to one of these galactic cities. Its spiral arms shimmer, its core glows with the breath of billions of stars. Within its bounds, expansion is meaningless, the stars orbit, as if the universe beyond were standing still. It's a comforting illusion, the kind nature often grants her fragile creations. Even as everything else races apart, life clings to its local harmony. A small sleepy joke forms in your head. Cosmic expansion is like an apartment lease with rising rent. Locally you're fine, but step too far from home and everything gets more expensive. You float above the galactic plane, watching hydrogen clouds swirl in slow motion. Each star is a sun, each sun a story. Yet as magnificent as it seems, you can't help noticing the emptiness between them. A light year of darkness separates almost every star. Scale that up and the gaps between galaxies become oceans, millions of light years of nothing. Expansion feeds on that nothing, not on the light. It grows where there's room to grow. Scientists still debate how these immense voids formed. Some think they're relics of quantum fluctuations stretched by inflation. Others say they're scars left by dark energy's uneven pressure. Whatever the cause, they define the modern universe 80% empty, 20% luminous. You're floating not through a crowd, but through a silence so vast it makes thought itself feel like an echo. You glance back toward your own galaxy. The Milky Way glows faintly against the infinite dark, a fragile swirl of gold and violet. You can almost hear it breathing slow and steady. For now, gravity keeps it safe, a small rebellion against expansion's rule. But even gravity has an expiration date. Someday the energy that binds its stars will fade and its remnants will drift away into the universal tide. You think about how humans once imagined the universe as infinite and eternal, but in truth it's both infinite and temporary, endless, in space, finite in memory. The further expansion carries it, the fewer stories it can tell. There's a strange peace in that though. Each galaxy is a capsule of light, a self-contained sanctuary of time. Inside atoms recycle, stars die. Planets form the same chemistry, playing out again and again, unaware of the growing void around them. Life wherever it appears will always feel central, always think itself the main event, because darkness never writes reviews. You drift through that darkness, now weightless, unhurried. You realize that expansion doesn't mean chaos, it means room. Without it, there'd be no place for galaxies to form, no space for gravity to work its art, no silence for meaning to echo in. A gentle laugh rises, the kind that feels like a sigh. The universe may be expanding, but inside every small island of light there's still warmth, still conversation, still connection. Maybe that's the lesson hiding between galaxies. The spaces between things are what make beauty possible. The distance gives perspective, and perspective gives awe. You gaze once more at the endless black between the clusters. It looks empty, but it's alive with stretched light-invisible radiation, drifting neutrinos, the quiet hum of everything too patient for your eyes. You let it carry you soft as breath into the deep calm of a universe that never stops giving itself more room to exist. The light dims further, and the quiet becomes almost absolute. The galaxies that once crowded your horizon now shimmer like distant memories, their glow faint red and tired. Expansion has done its work. The great cosmic web is loosening the threads, thinning, and the stars that once promised eternity are beginning to fade. You are entering the universe's slow twilight, the age when even light begins to forget. Mainstream fact: first stars do not live forever. The most massive ones burn bright and die young in supernova fireworks, scattering heavy elements into space. The smaller ones, red dwarfs, which make up most of the stellar population, burn so slowly they can last trillions of years. But even they in time will cool and dim into invisible embers. The night sky, already vast, will someday be almost empty. You picture it a cosmos where new stars no longer form, because the raw materials, hydrogen and helium, have been used up or locked away in dead remnants. Galaxies still exist, but they no longer shine. The universe becomes a graveyard of quiet matter, each galaxy a city gone dark, its streets cold, its windows shuttered. The quirky bit some astrophysicists call this future era the degenerate age. Not because the universe loses its morals, but because it's ruled by degenerate matter, white dwarfs, neutron stars, black holes. It's the end of starlight and the beginning of quiet physics. Imagine a sky filled not with stars but with silence so dense it almost hums. Scientists still debate just how long it will take for the last star to die. The estimates stretch so far they become surreal. 10-14 years for red dwarfs to cool, 10-39 for protons to possibly decay. The numbers are so large they mock imagination. Your human brain tuned for minutes and seasons can't hold them. Time in that era becomes geological, then glacial, then meaningless. You drift among the last lights. A single red dwarf still burns ahead, its glow faint but determined. Around it a frozen planet orbits in slow motion. No warmth, no oceans, just frozen nitrogen plains, glittering faintly in the dim starlight. The air, if it can still be called that, would freeze solid against your skin. Yet the planet moves faithfully one last waltz with its dying partner. A soft, ironic thought crosses your mind: the universe began in fire and ends in loyalty. Every orbit is a promise kept long after the warmth is gone. You move on. The space between galaxies is now almost absolute vacuum. Cosmic expansion has stretched the background radiation so thin that its temperature has dropped to near nothing, perhaps a fraction of a degree above absolute zero. The universe, once brilliant and noisy, has become a slow exhalation of cold. Somewhere behind you, black holes still exist, slowly evaporating through hawking radiation. They are the final storytellers whispering their last energy into darkness. Each one shrinks photon by photon until it vanishes in a faint spark, the last flicker of structure before the long night. Scientists still argue whether information truly disappears when a black hole dies. Some insist it's preserved in subtle correlations within the radiation. Others suspect the universe simply forgets. Either way, by then there's no one left to care. The cosmos becomes not a drama, but a slow drift toward equilibrium. You try to imagine what night means when there are no eyes left to see it. There's a paradoxical peace in it, a stillness so complete it transcends sadness. Expansion continues, but there's nothing left to stretch. Space grows emptier, the speed of cosmic separation approaching a kind of infinite lethargy. A sleepy little joke arrives unbidden. The universe, after billions of years of chaos and brilliance, finally takes a nap. It earned it. You float through this late universe as though through a museum of endings. Here a remnant white dwarf glows faintly its light, a billion-year-old whisper. There a dead galaxy cluster drifts apart, its ancient stars long gone. The once fiery cosmic web is now just memory. The scale of silence is so vast that even thought feels like trespass. Yet in this quiet, something oddly familiar remains. Order, patience, persistence. Expansion didn't destroy beauty, it distilled it. The chaos of youth becomes the calm of age. The universe has gone grey, but gracefully. Scientists still debate what happens after this deep freeze. Some predict quantum resurrection, rare fluctuations in the vacuum that could spawn new universes, bubbles of creation rising from the ashes of entropy. Others call that wishful thinking a mathematical mirage. But even they admit the laws that once birthed your cosmos are still here, woven into the empty space. Possibility itself never dies, it just hibernates. You take one last look at the cold horizon. In the distance, a lone photon drifts by, maybe the last one. It's stretched beyond colour, beyond heat, beyond recognition, but still moving, carrying the faint memory of its beginning. You let it pass through you, and for a brief second you feel the entire history of light, its birth, its travel, its fading. It's not sad, it's complete. Maybe this is what eternity really looks like, not an endless party, but a final exhale into stillness, where even time sighs and lies down beside you. The stars go silent, the galaxies drift away, and all that remains is motion itself, the faint pulse of expansion, the universe's last lullaby. And as you drift with it, you realize that you're not watching the universe die, you're watching it rest. You drift in that eternal night until something unexpected appears, not light but movement. A distant shimmer, subtle as breath, pulls your attention across the void. It's not another galaxy, not another dying star, it's Andromeda. Even in this expanding universe, one thing still dares to move closer. The mainstream fact, the Milky Way and Andromeda are on a collision course. Despite expansion, local gravity between the two massive galaxies overcomes the cosmic push. In about 4.5 billion years, their mutual pull will bring them together at speeds of roughly 110 kilometers per second. The result won't be an explosion, but a slow, spectacular merger, a celestial embrace lasting millions of years. From a distance, it won't look violent. The stars inside both galaxies are so far apart that very few will actually collide. Instead, the galaxies will pass through each other, their shapes distorting into long, luminous tidal tails. The gas clouds will compress sparking waves of new starbirth. It'll be chaos, but creative chaos, the universe's favourite kind. Here's the quirky part when that happens. Earth, if it's still here, will witness the night sky transformed into a painting of fire and silk. Andromeda will grow each night until it fills the heavens with arcs of light. Eventually, both galaxies will blend into one giant elliptical system, humorously nicknamed Milkomeda. Future astronomers, if any exist, will look up and see not two spirals, but one enormous golden blur. You float between them now, watching gravity work its ancient magic. Despite all the expansion, despite all the pushing apart, this is proof that the universe still believes in reunions. Gravity may have lost the big war, but it still wins the local battles. It's the friend who always shows up, even when everyone else has drifted away. Scientists still argue over the fine details. Will the merger ignite a supermassive black hole at the centre, or create a quiet equilibrium of twin giants orbiting each other? Will our solar system be flung into the galactic halo, or swallowed by the core's brilliance? The simulations disagree, but one thing is certain. The night sky will never look the same again. You imagine it vividly, two disks of stars colliding in slow motion, spirals intertwining like cosmic dancers. Gas clouds collide and glow, new suns are born, old ones scatter like sparks from a forge. It's both ending and beginning at once, galaxies dying as individuals but reborn as one. Expansion may rule the cosmos, but gravity writes the poetry. A light laugh escapes you, even galaxies, it seems, can't resist drama. Billions of years alone and they still end up in each other's arms. In the merging core, chaos settles into rhythm. Supermassive black holes, one from each galaxy, spiral toward each other, shedding energy in gravitational waves that ripple through space-time itself. You can almost hear it like bass notes, too low for ears, a subsonic hum that shakes the void. When they finally meet, they merge into one, forming a singular giant, a gravitational monarch at the heart of Milkomeda. Scientists still debate how much energy such collisions release. The merger of two black holes can outshine every star in the universe for a brief instant, but not in light and gravity. Detectors like LIGO and Virgo have already caught echoes of smaller mergers, tiny preludes to this grand finale. The fact that humans, tiny primates on a small rock, managed to measure ripples in space-time at all feels absurd and beautiful. You're in a sense already listening to the future symphony of your galaxy's fate. Andromeda draws closer now, filling your cosmic field of view. Its stars mingle with those of the Milky Way until boundaries blur. You realize this isn't destruction, it's consolidation. Even as the universe expands, it also gathers fuses and recombines. The cosmos loves both dispersion and reunion, both solitude and togetherness. It's not one or the other, it's the rhythm between them. A soft joke surfaces if galaxies had dating profiles. Theirs would say long-distance relationship but willing to travel. In the end, when the two become one, their stars will orbit in smooth ellipses, no longer spiraling, just gliding through the collective halo. The Milky Way's iconic arms will be gone, replaced by a calm, egg-shaped glow. Fewer new stars will form. The era of abundance will fade and the great quiet will return. But before that happens, there will be a moment, maybe 1 billion years long, of pure splendor, hundreds of billions of suns lighting up the sky, at once fireworks written in hydrogen and gravity. You hover at the edge of that collision and realize how strangely human it feels. Every meeting in your life, every collision of hearts and ideas carries the same physics attraction. Exchange, transformation, release. The universe doesn't just expand, it learns to come together again in new forms. Scientists still debate what Milkomeda will look like after 1 trillion years. Will it become a faint red fading ember adrift in accelerating space? Probably. But tonight in your drifting imagination it's alive, a celestial waltz frozen in time. You look one last time at that merging glow. Expansion continues all around, unstoppable, unhurried. Yet right here gravity has carved a sanctuary, a brief island of reunion, in a sea of retreat. And you understand something quiet but profound, even in a universe that never looks back sometimes for a few billion years, two galaxies still do. You drift above the aftermath of that colossal dance, two galaxies now folded into one luminous body. The airless silence of space hums with the ghost of the collision, but it's over. The stars have settled, the fireworks have dimmed, and what remains is calm, a vast elliptical glow adrift in endless black. The universe as always moves on, Now begins the age cosmologists call the Cold Empire the long, slow winter of creation. Everything still expands, but the expansion has outpaced the making of new things. The galaxies glow faintly, but the factories of light are closing. The cosmos, once a teenager burning with energy, has grown into something quieter, more patient, and infinitely more still. The mainstream fact stars are a finite resource. The great reservoirs of cold hydrogen that fuel stellar birth are dwindling. As galaxies mature, their gas clouds are either converted into stars or stripped away by gravitational tides. Each generation burns faster and leaves less behind. The stellar birth rate peaked about 10 billion years ago, the cosmic noon, and has been declining ever since. You look around and see the results. The spiral arms that once shimmered with young blue stars now glow faintly red. The massive short-lived giants are gone. What's left are the elderly, the slow-burning dwarfs, long-lived but dim. Across the universe, a subtle colour shift occurs. The galaxies redden. The light of creation softens into the light of endurance. The quirky bit some astrophysicists predict that in the far future, when gas runs out, new stars might form in a completely different way from the merging of brown dwarfs or the collisions of rogue planets. These second-generation stars would be rare and faint, burning coolly for trillions of years. The universe would not stop making light entirely. It would simply learn to make it more quietly. You glide past Andromeda, now a mellow golden haze. Around its core, the supermassive black hole, newly merged and fattened, rules with serene authority. It pulls stray stars inward, devouring one now and then, releasing brief flares of radiation like candle sparks. But even those bursts grow rarer. The black hole too will eventually starve. Scientists still debate what the final balance will be between dark energy's outward push and gravity's inward whisper. Will galaxies drift completely beyond each other's horizons? Almost certainly. Will the expansion accelerate forever? Most evidence says yes, but how dark energy behaves over the next trillion years that remains the grand unknown. Maybe it will strengthen and rip everything apart, or weaken and freeze the expansion into permanence. Either way, you're watching the tempo slow. You sense it in the silence. Photons stretch until their wavelengths span light years. Neutrinos drift colder than memory. Time itself begins to lose texture. Events stretch so far apart that the concept of now becomes meaningless. The cosmos is still expanding, but the story feels like it's being told in whispers, one syllable every million years. And yet beauty persists. The quiet sky glows faintly with the accumulated light of all things past a diffuse cosmic nostalgia. It's like the aftertaste of warmth, not heat itself, but the idea of it. The universe has entered its contemplative phase. A light joke flickers after 13 billion years of explosions. It's understandable that the cosmos just wants a nap and a cup of tea. You drift closer to one of the remaining stars. It's a red dwarf, small and stubborn, radiating softly into the dark. Around it, a planet still circles faithfully its surface, frozen solid, its atmosphere long gone. But beneath the ice, tidal heat and chemistry continue to whisper. Maybe not life, but the shadow of life molecules still experimenting in the cold long after the main show ended. Scientists still argue about how long consciousness might survive in such a cosmos. Could some intelligence adapt, feeding on the faint glow of decaying particles stretching each thought across millennia? Some think yes. Others say entropy is too strict a teacher. Still, the idea lingers that awareness like light doesn't vanish, but merely lengthens its wavelength until it becomes indistinguishable from the background. You look outward again. The universe seems calm, but every part still moves, obeying the same expansion that began with the Big Bang. Nothing escapes that rhythm, not galaxies, not stars, not even atoms. Over unimaginable timescales, the protons inside matter itself may decay, releasing their last energy in a final quiet shimmer. Everything that was solid becomes light, and everything that was light becomes distance. The cosmos, once defined by creation, now defines itself by persistence. It's not dying. It's transforming into the simplest possible state, smooth, even unhurried. Entropy isn't destruction, it's completion. You breathe slowly, synchronizing with the universe's fading pulse. There's a tenderness in this vast cooling, a reminder that every burst of life and fire was borrowed, time repaid, now in calm. The stars were bright because they were temporary. The darkness is kind because it's forever. A quiet thought surfaces expansion, and cold aren't failures, they're balance. Without an ending, beginnings would mean nothing. Without the stretch of silence, the first note of creation would have had nowhere to ring. You drift deeper into the dim, realizing that even as everything grows distant, you've never felt more connected. Every atom of you was made for this, forged in the early furnace, scattered by supernovae, carried outward by expansion, now floating in recognition of its own cosmic origin. The Cold Empire isn't an ending. It's the exhale after a long song, the part where the echo lingers, and you can finally hear how beautiful the silence is. You drift on past the soft red hush of the Cold Empire into rumour territory, the kind of idea whispered across late-night physics conferences, half joke, half warning. Someone once called it phantom energy. It's the theory that dark energy, instead of staying steady, might keep growing stronger. If that ever happens, expansion wouldn't just stretch the gaps between galaxies, it would tear apart everything right down to the fabric of atoms. The mainstream fact current observations hint that dark energy acts like Einstein's cosmological constant, unchanging serene. Its pressure-to-density ratio, called W, sits close to 1. But if W1 even by a hair, the energy of empty space increases as the universe expands. That feedback loop leads to a runaway finale nicknamed the Big Rip. In this model, galaxies unbind first, then stars, planets, molecules, and finally space-time itself. The quirky bit, when the idea first appeared in the early 2000s, one theorist drew a timeline on a napkin billions of years from now, the Milky Way dissolving. 30 minutes before the end, the Earth shredded, fractions of a second before atoms stretched like taffy. At 0, even the metric equation stopped making sense. It was equal parts nightmare and performance art, a cosmic stand-up routine delivered in Planck units. Scientists still argue fiercely over whether phantom energy is real or just a mathematical misbehavior. Observationally, WWs could be 1.03 or 0.97. The difference hides in uncertainties smaller than your heartbeat. New missions like Euclid and Roman will keep measuring, chasing the universe's handwriting out to the third decimal place. Somewhere in those digits hides your cosmic weather forecast, eternal calm, gentle chill, or terminal disassembly. You picture it anyway. 1 trillion years from now, dark energy begins to climb subtle at first. Galaxies drift apart faster, then faster still. Gravity loses jurisdiction. Expansion invades the neighborhoods it once respected. Clusters unbind. Stars slip their orbits. The sky thins until even your home galaxy is a solitary ember swallowed by speed. Then comes the local unmaking. The sun, whatever form it has by then, feels the tension first, its plasmatides stretched outward. Planets are peeled away, moons, uncoupled atmospheres lifted like silk. Eventually, even molecules cannot hold. The electromagnetic force surrenders to geometry. Matter frays into its elementary threads, and those threads lengthen until distance itself dissolves. A dark laugh surfaces the ultimate yoga pose, the universe achieving infinite stretch. But before you panic, remember, it's only one hypothesis, a mathematical ghost story told around cosmological campfires. Most evidence still favours a quieter ending, the slow dimming of the Cold Empire you just left. The Big Rip remains an exercise in humility, a reminder that every constant in physics is a question mark wearing a tuxedo. You drift through this hypothetical apocalypse strangely serene. There's beauty in the symmetry, the same expansion that once pulled matter out of the Big Bang could one day return it to energy, completing the loop. Creation and dissolution become mirror gestures. The universe, ever polite, cleans up after its own party. Scientists still debate what happens after a rip. Some speculate that the tearing might spawn quantum bubbles, new universes budding from the wreckage, each with fresh laws and new values of W. Others think it's truly the end, a curtain call with no encore. Either way, there's something comforting in the thought that existence refuses to waste energy. It merely repackages wonder. You let that vision fade. The galaxies return to their steady red drift phantom energy back in its bottle. The sky looks ordinary again, or what counts as ordinary in a place where space itself breathes. The memory of that possible unravelling lingers like the aftertaste of adrenaline. You realise that fear of endings is a luxury of the living. The universe feels no dread, it only continues. A quiet joke cosmologists promise that if the Big Rip happens, they'll send a postcard, though postage rates at that expansion rate might be prohibitive. You watch expansion stretch beyond sight, and somehow the idea of it all coming apart doesn't feel tragic anymore. It feels honest. Nothing was ever truly bound. Every connection was borrowed time, And yet in those temporary bindings, atoms, stars, hearts, the universe found ways to see itself. Even if phantom energy wins, it can't erase that brief self-recognition. You exhale, matching the cosmic rhythm. The fabric may stretch to infinity someday, but right now it simply flows around you, gentle, endless, unbroken. The night is vast, the math uncertain, but the feeling, that quiet awe of existing inside a question that remains. You drift beyond the realm of endings and into the beginning that never stopped, that first impossible moment, when everything started moving faster than light, when expansion wasn't a gentle stretching, but a violent bloom. You're entering the era physicists call inflation, a time so brief that its entire history could fit between the beats of a hummingbird's wings, and yet it shaped everything that followed. The mainstream fact inflation theory proposes that in the first 1036 seconds after the Big Bang, the universe's size doubled again and again, expanding by a factor of at least 1026 in less than a blink. Space itself ballooned faster than any speed powered by a mysterious field of energy, the inflaton. When it ended, that energy transformed into particles, radiation, and heat. The uniformity of today's cosmos, the evenness of the microwave background, the flatness of space are all fingerprints of that unimaginable inflationary breath. You try to picture it, but the numbers are defiant. Before inflation, the entire observable universe, everything you'll ever see, fit into something smaller than a proton. Then, in an instant, it expanded to cosmic proportions. It didn't explode outward, it became outward. It's not space filling emptiness, it's emptiness making more of itself. The quirky bit inflation wasn't invented to sound dramatic. It was a desperate solution to two long-standing problems, the flatness and horizon puzzles. Why does the universe look the same temperature in every direction, even in places that should never have been in contact? Inflation answers that by saying they were in contact once, before being yanked apart faster than light. Its cosmic sleight of hand, the universe stretched so fast it froze its own smoothness. Scientists still argue whether inflation actually happened, or if it's just the best myth our equations can tell. Competing theories string gas cosmology, ekpyrotic universes, quantum bounce models, whisper that maybe expansion came from a collision of higher dimensional brains, or a previous universe rebounding from collapse. Inflation is elegant but untested at its core. It fits the data perfectly, which sometimes makes theorists nervous. Perfect fits can be masks for ignorance. You watch that first moment unfold. Imagine energy density so high that gravity itself behaves like a quantum wave space frothing like boiling water. Tiny fluctuations, quantum jitters get inflated into macroscopic features. Each one becomes a seed for galaxies, stars, maybe even you. The largest structures in existence were once microscopic uncertainties, noise that the universe decided to amplify into architecture. A soft joke inflation is proof that even the universe started with overconfidence and a lack of impulse control. You drift through that primordial turbulence, the airless dawn before atoms existed. Temperature 10 trillion degrees. Density near infinity. Time meaningless. The universe didn't ignite. It was already bright beyond comparison. Yet paradoxically, there was no light to see, photons couldn't travel freely. Space was opaque, dense, with particles in constant collision. Creation began not with illumination, but with pressure. Scientists still debate what triggered inflation to end. Did the inflaton field decay into matter through quantum tunneling? Did it roll slowly down a potential hill, leaking energy as radiation? Every version ends with the same poetic image, the universe reheating, a sudden conversion of pure geometry into everything that exists. You can almost hear it, not a bang, but a soft shh, the sound of space releasing heat into itself. When inflation stopped, expansion slowed but never ceased. The universe kept growing just at a more civilized pace. But inflation left behind something profound: structure. Those tiny differences in density, 1 part in 100,000, became the map from which everything formed. You're here tonight because quantum uncertainty refused to be quiet. You float inside that early fire, and it feels oddly familiar, not visually, but emotionally. There's chaos, yes, but also inevitability. Each burst of energy, each flicker of imbalance contains the blueprint of galaxies, and the eventual echo of your own heartbeat. You're literally watching potential energy fall in love with itself. Scientists still argue whether inflation was a one-time event or an eternal process. Some models predict that even as our patch of universe finished inflating, other regions kept going endless bubbles, each expanding into its own reality. That's the seed of the multiverse idea, universes budding off like foam on cosmic seas, each with its own physics, its own constants, its own kind of story. For now, you stay within your own bubble, suspended in its quiet aftermath. The fire cools, the first particles form, and expansion takes on rhythm. Time becomes meaningful, distance begins to matter. The universe, once an infant screaming itself into being, finally exhales. A last flicker of humour before the calm inflation may have lasted less than a trillionth of a second, but in that moment the universe set the precedent for everything else. Dramatic entrances, messy outcomes, and unanswered questions. You drift back into the present, still carrying that image of impossible speed. Inflation ended billions of years ago, yet its fingerprint lies in the sky above you tonight. Tiny variations in the cosmic microwave background measured to absurd precision by satellites named WMAP and Planck. Every pixel of that ancient light is a fossilized vibration from that first breath. You breathe with it now, slower, calmer understanding that even the wildest expansion eventually finds equilibrium. Inflation wasn't an explosion, it was a pulse, a heartbeat that set eternity in motion. And in a way, you're still inside that beat, feeling it through every atom that once rode the wave of the universe's first and greatest inhale. You're still floating in that newborn cosmos, but now the glare of pure energy begins to soften. The wild inflationary sprint has ended, space exhales, and the first ingredients of structure quietly begin to stir. It's a strange calm after unimaginable speed, like the air settling after thunder, except the air itself is still being invented. The mainstream fact: within the first fraction of a second after inflation ended, the universe entered what physicists call reheating. All that potential energy locked in the inflation field transformed into a storm of particles, quarks, electrons, photons, and instant plasma of creation. Temperatures soared to 1 trillion degrees, and yet this was the beginning of order. From randomness, patterns emerged. You picture it a fog of charged particles flashing in and out of collision, but with tiny irregularities, microscopic fluctuations left over from quantum uncertainty during inflation. These ripples in density, no bigger than subatomic jitters, would become the seeds of galaxies. Each one a future star nursery, a cosmic what if that grew into entire worlds. The quirky bit: some cosmologists call this era the quantum origin of everything visible. It's a simple but astonishing claim. Every mountain cloud heartbeat and memory started as a flicker in quantum foam, magnified by expansion into something macroscopic. You could say existence itself is built on amplified uncertainty, a kind of cosmic improvisation that somehow kept the rhythm. Scientists still argue over the exact mechanics. Some favour slow-roll inflation, where the energy field gently declined and reheated the cosmos. Others suggest hybrid models where multiple fields interacted like overlapping waves. There's even speculation about warm inflation, where reheating wasn't sudden but gradual, the universe simmering instead of detonating. Each model rewrites the story slightly, but the melody stays the same: chaos cooling into structure. You drift through that primal plasma. The light is blinding but not yet visible. Photons can't travel far before bumping into free electrons. Space hums with pressure wave sound, in a sense, though nothing like air. The universe itself is ringing, oscillating with acoustic ripples that will one day freeze into the cosmic microwave background. If you could listen to it, it wouldn't sound like music, but like deep rolling thunder vibrations crossing light years, the first symphony played on a cosmic drum. And within those sound waves are the first blueprints of galaxies, the echoes that will decide where matter clumps and where voids remain forever empty. A sleepy joke drifts through you: the universe invented bass before it invented treble. You imagine following one of those ripples. It swells, cools, and collects matter. Gravity begins to assert itself gently, turning density into destiny. Regions just a little heavier than their surroundings start to slow the expansion locally. They will collapse over billions of years, becoming the scaffolds of galaxies. All of this from tiny quantum differences like wrinkles frozen into cooling glass. Scientists still debate how these first quantum seeds transition into the large-scale structures we observe. The math connects quantum mechanics, thermodynamics, and general relativity, three pillars of physics that famously dislike each other's company. And yet somehow, they cooperated just long enough to make everything you know. That cooperation is still one of the greatest unsolved mysteries of science. You drift further and the heat falls. Protons and neutrons begin to form nuclear chemistry's first act. Hydrogen dominates, helium follows, and a trace of lithium sneaks in. The elements of the future universe are cast in their simplest forms, born not in stars but in that first universal forge. When you look at the sun billions of years later, most of what you see was created right here in the first 3 minutes. The light can finally start to travel just a little. The universe becomes transparent enough for radiation to move, though still hazy. Expansion continues, but the mood has changed, less violent, more deliberate. Time stretches, seconds turn to minutes, minutes to centuries. You can almost sense the physics catching its breath. A quiet wonder takes over you. The first structure in the cosmos isn't a galaxy or a planet, it's pattern itself. Tiny differences, faint rhythms in density are the original architecture. You think of sand dunes forming under wind or ripples in still water, how beauty always starts with repetition. The universe didn't begin as art, but it can't help creating it. Scientists still argue whether quantum fluctuations truly came from nothing. Some suggest a pre-existing quantum field that fluctuated eternally. Others whisper about multiverse inflation, each region bubbling with its own constants. Either way, what you're seeing now is the first translation of potential into reality, the point where maybe becomes is. You pause and the realization lands you. The listener are built from those same fluctuations. The atoms in your hands are older than light, forged from the earliest tremors of existence. You are quite literally made of the universe's original uncertainty. A quiet laugh escapes you. It's oddly freeing. Perfection was never the plan. Every flaw, every difference, every irregularity that ever led to life or love started as a quantum quiver that refused to cancel out. The fire fades a little more. The plasma cools to a dull red. The first atoms form, the first light escapes freely. The universe takes its first clear breath. Somewhere deep inside it, the faintest shadow of structure begins to coalesce, invisible, yet inevitable. You drift with it, weightless, warmed by a history so ancient it feels like a memory rather than a fact. You realize the most profound truth of all the universe didn't come from perfection. It came from fluctuation. It grew not by eliminating chaos, but by nurturing it. And maybe that's the quiet message of the cosmos. Creation isn't control, it's permission. You float through the cooling fog of the newborn cosmos until something curious stirs at the edges of thought, a sense that maybe this isn't the only universe there is, that perhaps the bubble you've been drifting in is just one among countless others, each expanding into its own horizon, never touching, never knowing. The multiverse, the idea that what you call everything might only be one room in a mansion with infinite doors. The mainstream fact, modern inflation theory naturally predicts that inflation never ends everywhere at once. It's eternal inflation, a self-sustaining process in which quantum fluctuations cause some regions of space to keep inflating, while others cool and form universes like ours. Each bubble becomes a separate cosmos with its own Big Bang, its own physics, its own possible versions of chemistry, stars and life. We're living inside one such bubble adrift in an eternal sea of expansion. The quirky bits and physicists, notably Andre Lindy, compare eternal inflation to popcorn. Each kernel pops into a universe. Some pop early, some late, some never stop. The foam between them inflates faster than any communication could bridge. So even if other universes exist right next door, we'll never see their light, the cosmic equivalent of living beside a wall that grows faster than you can build a window. Scientists still argue whether the multiverse is science or philosophy. It can't be directly observed, each universe is causally disconnected from ours. Critics say it's like adding infinite sequels to a story, because you can't decide on an ending. But the equations don't care about taste. Inflation once started wants to keep going. Even if it's unprovable, it may simply be true. You imagine drifting above this infinite foam. Each bubble glows faintly, some long-cooled, some still, forming others, bursting with strange laws of physics. In one, gravity might be stronger, compressing stars into black holes before they form. In another, the cosmological constant could be weaker, letting the universe collapse within seconds. A few might host life. Most would remain sterile. You're not special, just in one of the rare bubbles where the math happened to allow stability long enough for curiosity to appear. A sleepy joke whispers through you, you're not the center of the universe. You're a lucky bubble in cosmic bubble wrap. You drift closer to the edges of your own universe, not physically because edge is the wrong word, but conceptually. The horizon that defines what you can see is expanding, but beyond it lies everything you can't, endless versions, each with its own constants, its own time. Some cosmologists believe there could even be identical copies of you formed by chance in other regions so vast that every possible arrangement of atoms eventually repeats. Somewhere a twin of you is reading these words for the first time, somewhere else for the last. Scientists still debate how to interpret probability in an infinite multiverse. If everything that can happen does happen, then what does likely even mean? Some propose the anthropic principle, the idea that we observe this particular universe because only this kind allows observers. It's not arrogance, it's selection bias written in cosmic font. You can't see other universes, but you might catch their fingerprints. Some theorists predict that if two bubbles ever collided, they'd leave circular scars in the cosmic microwave background, faint rings where their expanding walls touched. Observers have searched for such imprints. None are confirmed, but a few anomalies remain cold spots and subtle asymmetries that make you wonder if we're truly alone. You let your imagination wander through those neighbouring realms. Maybe one universe has 3 spatial dimensions like ours. Maybe another has 4 where gravity is too intense for atoms to survive. Perhaps somewhere, the arrow of time runs backward and expansion feels like collapse. Somewhere else, dark energy doesn't exist at all, and galaxies never drift apart. Its dizzying yet comforting existence diversified through endless trial and error. A quiet smile crosses your mind. The multiverse, if real, is nature's way of saying she never throws away drafts. You realize something subtle as you drift between the imagined bubbles. The concept of expansion changes meaning here. Each universe grows within its own pocket of space-time, but collectively they're all part of a larger inflationary sea that never ends. Even as your universe matures, new ones are born beyond reach. Creation doesn't stop, it just moves elsewhere. The cosmos is an eternal relay race of beginnings. Scientists still argue about whether the multiverse idea cheapens meaning. If everything possible exists, do any choices matter? But meaning, you realize, doesn't come from uniqueness. It comes from awareness. Even if infinite versions of you exist, only this one is thinking this thought right now. Consciousness localizes infinity into one quiet breath. You drift back toward your own universe, watching the other bubbles fade. Their lights dim not because they end, but because expansion stretches the distance beyond recognition. You feel an odd tenderness for them, the unknown siblings of your cosmic family. Maybe they're still growing, maybe they're long gone, maybe they're dreaming of you too. A soft laugh. Physicists call the space between bubbles false vacuum, which feels unfair. It's not false, it's just waiting for its turn to become something real. You sink gently into your own universe, again, your bubble still glowing with its galaxies and cold light. The multiverse, whether true or myth, doesn't make you smaller, it makes existence larger. It means the act of being even briefly, even in one universe among billions, is still extraordinary. Somewhere inflation continues, new universes blooming silently into the dark. You close your eyes, and for a moment you can almost hear it, the soft crackle of creation still popping in the background, infinite, unstoppable, gentle. You drift back toward your own universe, its bubble still trembling faintly in the sea of possibilities, and you start to notice something invisible yet relentless, the direction in which everything moves. Not through space, but through time. It feels obvious to you, this flow from past to future, from what was to what will be. But in the physics of the universe, time isn't guaranteed to have a preferred direction. It's an emergent property, a byproduct of expansion and entropy. You're floating inside the reason time itself goes one way. The mainstream, fact the arrow of time, points forward because the universe began in a state of extraordinarily low entropy, extremely ordered energy condensed into a small region. As it expands, that energy disperses, systems mix, stars burn, and order decays into disorder. The total entropy rises, and with it the sense of before and after. Thermodynamics gives time its direction. Without it, the universe could play both ways like a film in reverse. The quirky bit, some physicists have wondered whether entropy could decrease in other universes, or even in hidden corners of our own, giving rise to regions where time runs backward relative to ours. They call these anti-time domains. The idea isn't fantasy. The equations of physics themselves are mostly time-symmetric. Nothing in the mathematics forbids a backward flow, only the boundary conditions set by that low entropy beginning. Scientists still argue whether such mirror universes could exist, perhaps born on the other side of the Big Bang, their arrows of time pointing opposite ours. You picture it somewhere beyond the singular veil, Another cosmos expanding in reverse, its stars unexploding, its civilizations unremembering. For them, entropy would still increase in their own sense of time, but to you, it would look like reversal ashes reassembling into trees, light collapsing into fuel words unspoken back into silence. The mirror might be real, or it might be metaphor, but it's a useful one. Every motion forward here is mirrored by decay into equilibrium elsewhere. Scientists still debate how the universe's expansion fixes this direction. Some describe the growth of entropy as space stretching, to make room for new possibilities. Others imagine time itself stretching with it each second slightly longer than the last as the cosmic scale factor grows. Either way, the act of expansion builds a temporal gradient, a slope down which existence slides effortlessly. You drift through that slope watching stars age and fast forward. Hydrogen becomes helium, helium becomes heavier elements, heavy elements fall into collapse. Each reaction leaves behind a little more disorder, a little more irreversibility. The future is simply the collection of things that can't be undone. A soft joke rises, the universe is basically the world's longest to-do list, where every item once checked stays checked forever. But there's beauty in that irreversibility. Without the arrow of time, there'd be no memory, no growth, no story. Every second you've ever lived is a small contribution to entropy, and that's not a tragedy, it's participation. You're part of the universe's act of becoming. Every breath you take balances on a cascade of irreversible reactions, tiny acts of forward motion written in chemistry. You start to think of entropy not as decay, but as texture. It's the grain in wood, the snow melting to make rivers, the leaf browning into soil. Entropy is how the universe paints movement onto stillness. Expansion provides the canvas, time is the brush stroke. Scientists still debate whether the arrow of time could ever reverse if expansion slowed or stopped. Some mathematical models show that in a contracting universe, a hypothetical big crunch times arrow might flip entropy decreasing as everything converged again. But because dark energy appears to drive eternal acceleration, that reversal seems unlikely. The cosmos won't rewind, it will fade. You float on realizing that even though physics allows symmetry, consciousness prefers direction. You can't unremember or unfeel. Your brain, like the cosmos, works by increasing entropy, burning glucose to maintain order locally while spreading heat overall. Life itself is a microcosmic version of expansion order sustained by releasing disorder. The future exists because you keep consuming the past. A gentle laugh stirs, so every thought you've ever had is really just the universe practicing thermodynamics. You look around at the galaxies and wonder, does each one have its own local arrow of time? In a sense, yes. Every cluster, every star, every atom ticks according to its own thermodynamic bookkeeping, but the overall direction stays consistent, outward, cooler, slower. You realize the whole universe is a synchronized wave of forwardness, and you are surfing on it without effort. Somewhere a supernova flares a dying star, scattering elements for new worlds. That explosion is entropy rising, yet it also creates opportunity. The same disorder that ensures the universe can't look back is the very process that makes complexity possible. Without entropy, no chemistry, no biology, no you. Time then isn't your enemy. It's the mechanism of creativity. Every heartbeat adds another grain to the cosmic sand pile, making room for something new. You drift quietly, letting that truth settle. The arrow of time doesn't need a reason beyond its own necessity. Expansion didn't just create space, it created sequence. The universe keeps moving forward because standing still would be impossible. You take a slow breath, matching the rhythm of the cosmic pulse. Forward, always forward, not because it must, but because that's what existence means. The farther you drift, the more you realize that time itself isn't the only thing pointing forward. Light does too. Everywhere you look, photons are stretching their once blue wavelengths, slipping toward red like music played at half speed. It's not just poetic, it's physical proof that expansion never sleeps. The universe is literally pulling color apart. The mainstream fact this phenomenon is called cosmological redshift. As space expands, it doesn't drag galaxies through it. It stretches the very waves of light traveling between them. Each photon's wavelength elongates in proportion to the universe's growth factor, double the size, double the wavelength. What began as ultraviolet fury from the first stars now arrives as a faint lazy whisper in the microwave band. It's how astronomers measure distance, and time. Light itself is the ruler quietly recording every inch of cosmic growth. You watch it happen. The light from a distant quasar passes through you, bright at first, then longer, softer, cooler, like an old vinyl record warping under heat. Its energy fades not because it tired, but because the universe made the path longer while it travelled. In a way, you're seeing the light's aging process, its slow drift from youth to old age. The quirky bit redshift isn't unique to cosmology. The same principle makes the pitch of a receding ambulance drop as it drives away the Doppler effect. Except here, it's not motion through space that matters, it's motion of space. There's a subtle joke cosmologists tell galaxies aren't really fleeing us. The universe is just expanding between us like an awkward friend insisting on personal space. Scientists still argue over the precise relationship between cosmological redshift and the Doppler shift of motion. At short distances, they're indistinguishable. At cosmic scales, the difference is philosophical. The mathematics blends both into a single story. Space grows light stretches, meaning travels slower. You drift through beams of ancient light, each photon carrying a timestamp older than any planet. Some were born before Earth existed, others left their sources when dinosaurs were sleeping. You realize the night sky is a museum where every exhibit moves away faster than its light can keep up. A gentle joke flits by, you've been ghosted by every star you've ever admired. But the melancholy fades quickly into wonder, because that ghosting is what allows astronomy to be time travel. Each extra bit of redshift is a step backward through epochs, quasars showing you the universe at 2 billion years old, the cosmic microwave background showing you infancy itself. The further you look, the younger the cosmos becomes. Expansion doesn't hide the past, it preserves it. Scientists still debate whether redshift could ever reach a limit. When wavelengths become longer than the observable horizon, the photon's energy effectively disappears from reach. They don't vanish. They just drift beyond communication, their frequency too low to interact with anything. It's called the cosmic event horizon. Beyond that, light is forever lost, trapped in the treadmill of expansion. You picture those stranded photons still moving but never arriving. It's almost tragic, except photons don't mind. They don't have destinations, only journeys. Every beam of light is a letter written by the past addressed to the future with no guarantee of delivery. You let one of those letters pass through you. It vibrates softly, a pulse so long you can barely call it a wave. For a fleeting instant, you feel the memory it carries a star that lived flared and died long before your ancestors learned to look up. The redshift doesn't erase the story. It elongates it, making it slow enough for your mind to read. Scientists still argue about whether dark energy will eventually redshift all light into oblivion. In a big freeze scenario, expansion never stops stretching every photon until space becomes perfectly black. The last visible glow would fade not with a bang, but with a sigh, wavelengths so long they'd loop around galaxies without hitting anything. You glance toward the faint line of the Milky Way. Even now, the starlight you see is slightly older, slightly redder, slightly stretched. Every second you watch, the distance grows. Yet somehow the feeling of connection deepens. Because that's what redshift really is, proof that separation can still leave a trace of warmth. A soft chuckle, maybe this is the universe's way of texting back message received, but delivered at .99, the speed of nostalgia. You keep floating. Light passes through you like breath, each beam older than the last. The color drains gently from the cosmos, blues fade to green greens, to gold gold, to red, and then to invisible heat. The night grows quieter, but rather than feeling loss, you sense a kind of intimacy, a slowing heartbeat that you can match. The more it expands, the more personal it feels. Because to you, as to any observer, the universe still looks centered. No matter where you stand, light redshifts equally in all directions. The expansion isn't happening away from you. It's happening everywhere, including within. You breathe and your breath feels in sync with that cosmic rhythm. Exhale, and space grows. Inhale, and light stretches a little further. Expansion isn't something distant. It's the reason everything can exist apart and still belong to one whole. The photons keep traveling. You watch them fade their last wavelengths, dissolving into the invisible hum that fills every direction, the afterglow of creation. And you realize that even when light runs out of color, it never stops moving forward. The light has stretched until it's almost gone, yet something still hums beneath the silence, a soft, universal whisper that wraps you like a warm blanket. It's not starlight or heat from nearby galaxies. It's older, purer, patient. You're feeling the faint afterglow of the Big Bang itself, The mainstream fact this glow is called the cosmic microwave background, or CMB, the oldest light in the universe, released about 380,000 years after the Big Bang. Before that, space was a dense plasma where photons couldn't travel freely. But as the cosmos cooled, atoms formed, scattering ceased, and light finally broke free. That first light has been travelling ever since, stretched by expansion into microwaves that now bathe every corner of space at a chilly 2.725 Kelvin, just a few degrees above absolute zero. You let that number sink in. 2.7 K, the entire universe wrapped in a temperature barely above nothing, yet still glowing faintly with its own memory. It's like the ghost of a campfire, the embers of creation still radiating softly through time. The quirky bit, when scientists first discovered the CMB in 1965, they thought it was a mistake, a hiss of pigeon droppings on the antenna. Arno Penzias and Robert Wilson spent weeks cleaning the horn-shaped receiver, convinced something was contaminating their data. Only later did they realize they'd found the fossil light of the cosmos. They weren't removing noise, they were hearing the universe's first whisper. You imagine it now, the hum surrounds you, a uniform wash of energy from every direction. But look closer, not perfectly uniform. Tiny fluctuations, 1 part in 100,000, dapple the sky. Those are the fingerprints of early density variations, the ones inflation stretch from quantum ripples into cosmic structure. Each faint spot represents a future cluster of galaxies, a future home for stars, planets, and maybe stories. Scientists still argue about the exact cause of those minute variations. Were they quantum noise, gravitational waves, or something deeper? Perhaps imprints of cosmic strings or relic particles from before. Inflation ended. Missions like COBE-WMAP and Planck mapped them in exquisite detail, yet the mystery lingers. The CMB is both a photograph and a puzzle, proof that perfection was never the goal. You drift through it, immersed in the light that birthed sight itself. There's no colour, your eyes can't see microwaves, but if you could translate them into sound, the CMB would hum like a deep resonant note across the universe. Scientists have done just that, turning temperature fluctuations into audible tones. It sounds like wind through reeds, haunting soft eternal. A sleepy laugh rises, you're literally listening to the oldest lullaby ever recorded. You trace one fluctuation across billions of light years. It swells into a web of structure galaxies forming like condensation on glass. The CMB isn't just a relic, it's a blueprint. From that faint pattern came everything, including the atoms in your bones. You're made of differences so small they once fit inside a decimal point. Scientists still debate whether the CMB hides signs of other realities. Some data suggest cold spots too large to be random possible scars of collisions with other bubble universes. Others dismiss them as statistical noise artifacts of cosmic variance. But even disagreement has beauty here. The map of the CMB is a shared meditation on the birth of everything. You feel its warmth, 2.7 K, just enough to remind you that the universe never fully went cold. Even in the vast emptiness, there's still a glow, faint but faithful. It's like a cosmic pilot light quietly keeping existence from absolute zero. A quiet joke flickers. After 13 billion years, the universe still hasn't figured out how to turn off the lights before leaving. You drift through that glow, and for a moment it feels like fog, soft, even endless. You realize that every direction you look is the past. The CMB doesn't surround you like a wall. It is your horizon, the farthest you can see into time. Beyond it lies only opacity, the era when light itself couldn't move. It's not the edge of space, it's the edge of memory. The photons that touch you now have travelled for almost 14 billion years, slipping through galaxies, dodging dark matter, stretched by expansion into long, patient waves. They left their birthplace when the universe was young enough to fit in a paragraph. You are literally bathed in ancient information. Every second, trillions of those photons pass through you. Unnoticed, telling the same story. We began hot. We expanded. We cooled. We remember. Scientists still debate the smallest details, the exact spectral shape, the subtle polarization patterns, the fingerprints of primordial gravitational waves. Each new measurement tightens our understanding yet deepens the wonder. The CMB isn't just a relic. It's a love letter from the universe to its future selves. You close your eyes and feel it seep into you. This isn't light you can see, but warmth you can know. The universe, for all its vastness, still holds your atoms in the same glow it gave everything else. It's a shared heritage of radiation, the common background that unites every particle, every being, every question. You breathe slowly, Expansion may pull galaxies apart, but this light still touches all of them. It's the quiet thread that keeps the universe a single fabric. And for now, floating here in the afterglow of creation, you understand something gently profound. The universe never really stopped shining, it just dimmed the light so life could fall asleep under the softest possible glow. The afterglow fades behind you and the universe grows darker, not silent, not empty, just mature. You're moving through a cosmos that has finally settled into rhythm. Expansion hums softly in the background, no longer frantic, like in its youth, but steady, confident, almost graceful. Stars are being born, galaxies collide and merge, elements mix and recycle. The universe, it seems, has entered its long middle age. The mainstream fact cosmologists call this the stelliferous era, the age of stars stretching from about 100 million years after the Big Bang to 100 trillion years in the future. It's the epoch you inhabit right now, the golden span when gravity and fusion dominate the stage. Everything you see in the night sky, every sparkle and flare belongs to this era. The balance between expansion and gravity creates a delicate choreography. Galaxies still drift apart, but within them stars ignite, burn and die. You drift above one such galaxy, a spiral of silver and blue. You can feel the warmth of its newborn stars and the cool shadows of its ancient clusters. Gas clouds swirl in its arms, collapsing under gravity into glowing cradles. Each birth sends ripples of light outward like pebbles tossed into the pond of space. The quirky bit star formation isn't random. It follows a kind of cosmic weather pattern, driven by turbulence, magnetic fields, and shock waves from older explosions. Some regions go through starbursts, rapid waves of creation, while others fall quiet for billions of years. Galaxies breathe, in a sense, inhaling gas, exhaling light. The Milky Way currently gives birth to about one new star every few years, a gentle rhythm compared to its youth. Scientists still argue about the exact balance between starbirth and death, and how dark matter influences that cycle. Dark matter, the invisible scaffolding of the universe, doesn't shine, but it shapes everything that does. Without it, galaxies wouldn't have formed at all. Ordinary matter would have drifted apart long before gravity could sculpt it. Dark matter holds the pattern, the hidden blueprint beneath the cosmic lacework. You imagine it an invisible web stretching across billions of light years, each strand heavy with unseen mass. Galaxies cling to it like dewdrops on spider silk. Expansion stretches the web slowly, but gravity holds its knots firm. You're not drifting through chaos, you're floating along the framework of order. A soft, sleepy joke arises. If dark matter had a dating profile, its bio would read, "Doesn't like attention, but keeps everything together." You glide deeper into one of those filaments and the scale of structure becomes overwhelming clusters of galaxies connected by glowing bridges of gas, separated by voids so immense that light can wander for hundreds of millions of years before finding company again. From here, you see the cosmic web as it truly is, a vast neural network pulsing with slow electrical grace. The resemblance isn't metaphorical, it's mathematical. The distribution of galaxies follows the same statistical patterns as brain neurons. You're floating through the mind of the universe. Scientists still debate whether that resemblance is coincidence or reflection. Perhaps structure itself, wherever it emerges, naturally arranges into networks. From synapses to galaxies, the same geometry of efficiency repeats. Maybe that's what expansion really does, not just make space bigger, but make connection possible. You drift past merging galaxies. They twirl and blend their shapes distorted by tidal forces. Streams of stars fling outward like paintbrush strokes. In the chaos, supermassive black holes at their centers spiral toward each other, preparing for collision. When they merge, they'll release more energy in gravitational waves than all the stars in the galaxy emit in light. And yet from here it looks serene, two whirlpools becoming one. You pause to watch a supernova ignite in the distance. A dying star collapses, rebounds and erupts, scattering elements across the void carbon-oxygen ion. You know those atoms. They're the ones that will form planets' oceans and perhaps in time eyes to see it happen again. A quiet thought flickers. The universe is recycling itself endlessly, and every flash of destruction is also an act of generosity. You pass through a nebula glowing pink and violet, the grave of old stars and the cradle of new ones. Expansion continues around it, but here locally gravity has carved a sanctuary, a place where collapse resists the general drift. You realize how often that happens, small systems defying the big trend. Humans do it too, building homes, families' meanings, tiny pockets of resistance against the ever-growing cold. Scientists still debate the fine balance between those two forces, the local gravity that binds and the cosmic expansion that separates. The tension defines everything, galaxies, atoms, relationships. Without expansion, the universe would collapse under its own weight. Without gravity, it would have scattered into nothing long ago. Life emerges in that narrow middle ground, the equilibrium between embrace and release. You smile at the symmetry of it. Expansion and gravity, inhale and exhale. The cosmos breathing itself into being. You drift on watching stars flicker and die, galaxies bloom and fade. Expansion ensures they'll never all collide, but gravity ensures they'll never be completely alone. Between those two truths, you sense the quiet secret of the universe. Nothing lasts forever, but nothing truly disappears either. Every atom that leaves one story joins another. Every photon stretched into darkness still carries memory. A gentle laugh if entropy writes the ending gravity insists on footnotes. The stelliferous era will last trillions of years, but you know its days are numbered. Someday the last star will fade and the universe will grow dark again. Yet right now, here in this moment of balance, it's breathtaking. The galaxies spin like lanterns in a cosmic festival expansion, carrying them apart, yet their light still touching across distance. You float among them, feeling neither lost nor small, just perfectly placed one conscious moment within the great breathing of time. You drift deeper into that luminous middle age of the cosmos, watching galaxies shimmer like lanterns, drifting down a slow-moving river of time. The fireworks of creation are still going strong, but something in the background has changed, a faint shift in rhythm, almost imperceptible. The expansion is beginning to accelerate. The mainstream fact around 5 billion years ago, cosmologists discovered that the universe's expansion wasn't slowing down under gravity as everyone expected, it was speeding up. The galaxies weren't just coasting apart, they were accelerating away as if pushed by an invisible force. That discovery, made through observations of distant Type Ia supernovae, shocked the world. It implied the presence of something vast and mysterious filling 68% of the cosmos' dark energy. You hover on the edge of that revelation, and it feels like standing in a field and realizing the wind isn't coming from any direction, it's coming from everywhere. Space itself is generating motion. The galaxies are just leaves caught in the current. The quirky bit, the scientists who found this acceleration in 1998 thought at first they'd made a mistake. Their measurements showed the distant supernova were dimmer than expected, too far away for a slowing universe. It took months to accept the truth. The universe, one physicist said, has lost its grip. You think about that phrase as you watch galaxies drift faster. Expansion was once like a ball thrown upward, gravity slowing it, but never quite stopping it. Now suddenly the ball is flying upward faster on its own, an anti-gravity that comes from nowhere, obeying no intuition. The cosmological constant, once Einstein's greatest blunder, rises from the grave, rebranded as dark energy. Scientists still argue what dark energy actually is. Maybe it's vacuum energy, the energy of space itself predicted by quantum mechanics. Maybe it's a new field, a kind of cosmic fluid that changes over time. Or maybe it's just the way gravity behaves on large scales, not attraction but repulsion beyond certain distances. Whatever it is, it's now the main character in the story of expansion. You float among galaxies that seem almost unaware of their own motion. Within each one, gravity keeps things cozy, stars orbit planets, circle black holes hum quietly in their centers. But on intergalactic scales, the distances grow larger and larger, the redshift stronger. It's as if every galactic cluster is in its own soap bubble, drifting away from all others in a sea that won't stop inflating. A soft, amused thought rises. The universe is expanding like a bad economy. Everything inflates and no one knows where the value goes. You glide between two distant clusters, the Virgo cluster home to your Milky Way, and the Hydra Centaurus supercluster, sliding away at thousands of kilometers per second. Between them lies vast silent darkness, a trillion kilometers of nothing. Expansion doesn't stretch matter, it stretches the nothingness between matter. The void itself grows. Scientists still debate whether dark energy's acceleration will remain constant or change with time. If constant, the universe's expansion will continue forever, asymptotically approaching emptiness. If dark energy strengthens, it could lead to the Big Rip, everything torn apart, even atoms. If it weakens, gravity might one day slow expansion again. The truth hides in a single number, the equation of state-parametered U, which defines how dark energy's pressure relates to its density. So far, all we know is it's close to 1, close but not necessarily exact. You feel that number in your bones, the universe's pulse, precise but uncertain. 1 decimal place could decide the fate of everything, yet no one panics. Instead, scientists build telescopes, collect data, refine models, and smile at the irony that the biggest force in the universe is the one least understood. A gentle joke flickers. Dark energy is like that friend who pays for dinner, but never explains how they afford it. You continue drifting, and the scale of separation becomes unimaginable. Every galaxy you pass is moving away faster than the last. Beyond a certain distance, light from them will never reach you again, not because it's too faint, but because space itself expands faster than light can travel through it. The cosmic horizon shrinks even as the universe grows. You realize that the more it expands, the less of it anyone can see. The observable universe, your bubble of visibility, is getting smaller in relative terms, like a spotlight in an ever-growing theatre. The stars outside that light aren't gone. They're just unreachable. The expansion writes its own kind of solitude. Scientists still debate the philosophical meaning of that horizon. Does the unreachable still exist for us, or is existence itself defined by what can be observed? The universe, as always, refuses to clarify. It just keeps expanding, patient and impartial. You pause for a moment and glance back toward the Milky Way. It's still visible, still spinning, but the faint outlines of other clusters are already dimming. In a few trillion years, only the local group, the Milky Way, Andromeda, and their satellites will remain bound together. Everything else will vanish beyond the horizon, as though the cosmos is tidying up, turning off lights room by room. A soft smile touches your thoughts. Maybe expansion isn't loneliness, maybe it's preservation. Each galactic island gets to keep its light, its memories, its stories safely sealed against interference. The universe is archiving itself. You drift in the growing quiet, and the meaning of acceleration begins to soften. It's not a runaway or a mistake. It's the cosmos taking a deep breath, releasing pressure, allowing itself to stretch. Even creation, it seems, needs space to exhale. You close your eyes and listen for that breath. Somewhere deep within the same pattern repeats heartbeats, thoughts, even your cells expanding and contracting. The universe isn't out there. It's inside you, playing the same rhythm at a smaller scale. And as galaxies drift away into darkness, you realize expansion doesn't separate what's connected by memory. It only gives the connections more room to echo. You drift deeper into that widening calm where the galaxies thin out and the darkness between them grows thicker, softer, quieter. The universe has become something else now. Not a stage for explosions, but a field for echoes. Expansion no longer feels like motion. It feels like breath, a long and patient sigh that never ends. The mainstream fact dark energy now dominates the cosmic budget, about 68% of all energy in the universe. Dark matter holds 27%, and everything, familiar stars, planets, atoms, light, makes up less than 5%. The visible cosmos, the part that paints your night sky, is just a thin frosting on a cake of invisibility. Space is ruled by what it refuses to show. You look around. The galaxies are still glowing, but they're fewer now, more isolated. The distances between clusters stretch until they're measured not in light years but in time itself. It's no longer meaningful to ask where something is only when it was. Light from the nearest superclusters has already crossed billions of years to reach you. Expansion keeps pulling them farther, making each photon a relic from a past that can no longer exist. The quirky bit, some cosmologists say that in the far future, distant galaxies will redshift so much they'll disappear entirely from view. Future astronomers, if anyone is still around, will look out into the night and see only their own galactic neighborhood floating in perfect darkness. To them, the rest of the universe will be gone, not just invisible but unreachable forever. The cosmos will appear small again, just as it did before humanity learned otherwise. A quiet laugh rises. Expansion is the ultimate magician's trick. It makes the audience vanish instead of the performer. Scientists still argue what this means for cosmic understanding. If information beyond the horizon is lost, does the universe still contain it? Or has reality itself moved beyond definition? General relativity tells you nothing truly leaves. It just recedes beyond communication. Quantum theory disagrees. It whispers that information like energy can't be destroyed. Somewhere, somehow, every photon still remembers. You pass through the faint glow of a dying galaxy. Its spiral arms have blurred into ellipses, its gas long gone. Only long-lived red dwarfs remain, tiny embers scattered across the dark. They'll burn for trillions of years, each one a candle defying the deep. You sense their patience, not heroic, just natural. Light doesn't mourn its fading. It simply continues until it can't. Scientists still debate whether dark energy is constant or slowly increasing. If it strengthens one day, even these quiet galaxies will be torn from one another, their atoms stretched thin, their bonds undone. But for now, everything holds together. The stars still orbit. The galaxies still spin. The universe hasn't ended. It has simply matured. You drift through one of those red dwarfs' planetary systems. The central star is faint, barely visible in infrared. Its planets are frozen, their orbits perfectly stable, quiet sculptures of geometry. Expansion doesn't touch them. Local gravity keeps them bound. It's the same pattern everywhere, small circles of order preserved within larger spirals of dispersal. The universe, for all its motion, still honors islands of stillness. A soft, sleepy joke floats up. Cosmic expansion is the ultimate long-distance relationship, everything drifting apart but still sending the occasional text in the form of starlight. The emptiness around you begins to hum. It's not sound, not exactly, more like awareness. You start to feel the scale of what's missing, and instead of fear, it fills you with gratitude. Every flicker of light, every brief starburst was an exception to the rule. The cosmos didn't owe you illumination. It gave it as a gift. Scientists still argue about the far future fate of this accelerating universe. 3 options dominate the debate: the Big Rip, where dark energy strengthens until everything tears apart; the Heat Death, where expansion continues forever, thinning matter and light into equilibrium; the Big Bounce, where expansion eventually reverses and everything collapses, perhaps to start again. Each version sounds final, but none truly is. Every ending in cosmology is just the next phase in a cycle too large for language. You drift between galaxies that are now too far apart for gravity to reunite. The darkness thickens, but it's not empty. It's full of stretched photons, ghost particles, and quantum fluctuations that flicker like static. Even nothingness is busy. Expansion doesn't create silence. It deepens the harmony. A faint pulse passes through you, the cosmic background radiation stretched now to wavelengths the size of planets. It's the last trace of that ancient heat you felt earlier. You realize it will continue stretching forever, fading but never gone. The universe, it seems, has learned how to whisper so softly it can last eternally. You let yourself drift with that whisper. You think about the atoms that make up your body, born in stars scattered by supernovae, now reassembled into consciousness that can understand its own impermanence. The same expansion that drives galaxies apart also gave you time distance and the chance to notice. Maybe that's the quiet miracle, not that the universe expands, but that something inside it evolved to care about the difference between near and far past and future. A gentle smile crosses your thoughts. The universe doesn't look back, but you do. And somehow that's enough. You exhale as if in answer to the cosmic breath. The light around you continues to stretch, patient, infinite. Every photon keeps its promise to move forward, even when no one is left to see where it goes. The light is thinning now, fewer stars, longer shadows, more dark than dawn. You drift through a cosmos that has begun to forget its own brightness. Yet somehow this dimming doesn't feel like loss. It feels like rest. The universe, having burned for eons, is learning to sleep. The mainstream fact in roughly 100 trillion year star formation will stop entirely. All the raw hydrogen gas will have been consumed or locked away. The universe will then enter the degenerate era, an age ruled not by light but by remnants. White dwarfs, neutron stars, and black holes will become the dominant architecture of existence. No new stars will ignite. Fusion, the fire of life, will be over. You hover above a dying spiral galaxy. Its core glows faintly, a dim golden ember surrounded by darkness. The arms that once spun with colour are faded, their gas long gone. Around them drift the leftovers, frozen worlds, wandering asteroids, dead stars cooling into invisibility. The Milky Way's great descendants. Andromeda, then the quiet clusters beyond, will all look like this someday. Delicate fossils of starlight. The quirky bit white dwarfs, the corpses of sun-like stars, cool so slowly that even after 1 trillion years they still glow faintly red. Eventually, after quadrillions more, they'll reach absolute darkness, becoming black dwarfs, solid lumps of degenerate carbon and oxygen, the quiet coal of the cosmos. None yet exist. The universe isn't old enough. You're living impossibly early when stars still sing. Scientists still argue about what happens to these remnants. Some calculations suggest black dwarfs might, after unimaginable spans of time, undergo quantum tunneling supernova rare bursts where carbon fusion resumes spontaneously, turning darkness into light for one last instant. Others think proton decay will erase them before that happens. The debate is mostly academic, but the idea that even dead stars can dream of one last fire is too poetic to ignore. You drift closer to one such white dwarf. It's the size of Earth, but heavier than the Sun, its gravity strong enough to bend the path of light. Its surface temperature has fallen to a few thousand kelvins, cool by cosmic standards, but it still glows softly, a lonely pearl in infinite dark. Around it, the ghost of a planetary system still circles shattered rocks, frozen spheres, ancient ruins. You imagine absurdly that one of those worlds once had life long before its sun collapsed. Perhaps they watched their sky dim the way you now watch galaxies fade. Expansion doesn't only stretch space, it stretches eras of meaning too. A quiet laugh somewhere in that cold future, maybe another being will whisper, "Remember when the universe was bright," and some remnant particle still wandering will hum in response. You look around and realize how much the texture of existence has changed. The universe is bigger, emptier, slower. Expansion continues, but now it feels more like erosion than growth. Gravity loses territory year by year. Where once there were tens of billions of galaxies in view, now only one or two remain visible. The rest have redshifted beyond reach, their light stretched longer than the size of the universe itself. Scientists still debate the fate of black holes in this era. According to Stephen Hawking, they slowly evaporate through Hawking radiation, leaking energy over unimaginable timescales. The smallest will vanish first. The largest may take up to 10 or 100 years to fade. That's a number so absurd it defies comprehension 10,000 billion times the current age of the cosmos. When the last one goes, only subatomic whispers will remain. You drift beside a black hole patient, a stone massive as a billion suns. Its event horizon is smooth, its pull absolute. Yet even it will not last forever. From its edges, virtual particles flicker, one escaping, one consumed. Slowly and visibly, the giant shrinks. It doesn't roar, it exhales. The end of gravity's empire will be quiet. A small joke surfaces: black holes are the universe's best accountants, always balancing energy books, but in the end they too go bankrupt. You move past it and the light grows even thinner. The sky is no longer full of stars but of absences. Every bright thing is a memory, yet even here beauty persists, the geometry of orbits, the shimmer of faint radiation, the persistence of motion. Nothing truly stops. It just slows beyond recognition. Scientists still argue whether the expansion itself could eventually outpace quantum fluctuations, freezing the vacuum into a static eternity. Others think quantum foam will persist forever, tiny particles popping into existence, ensuring that the universe never becomes perfectly still. Even in decay, creation finds loopholes. You begin to notice how expansion has become almost metaphysical, a concept more than a motion. It's not just stretching distance anymore, it's stretching meaning. Each passing epoch asks, what does it mean for the universe to exist when there's nothing left to observe it? A soft, tired chuckle comes to you. Maybe existence doesn't need witnesses. It only needs persistence. The degenerate era is long, cold and sparse, but it's not hopeless. Gravity still whispers. Particles still collide occasionally. Black holes still dance their slow waltzes before fading. Every process, no matter how faint, contributes to the same truth motion endures. The universe never truly stops expanding because expansion isn't an action. It's a property woven into the geometry of being. You float onward, the last light of the last star fading behind you. Darkness folds around, gentle and absolute. You wait for despair, but instead there's peace. You realize you're still inside the same story, just a slower chapter. Expansion hasn't left you behind. It's carrying you along softly, endlessly toward whatever comes next. You keep floating through the dim ancient universe where light has thinned to a whisper and gravity has become a suggestion. The stars are gone, the galaxies are ghosts, and yet space still expands calmly, evenly, as if following a memory too deep to stop remembering. The mainstream fact by now, most matter in the universe has transformed. Atoms have decayed or fallen into black holes, which in turn are evaporating through Hawking radiation. The cosmos is entering the black hole era, a chapter so long that time itself seems to blur. Between 1039 and 100 years from now, black holes dominate the landscape, each one a silent monument to what once was. You drift near one. It's enormous, perhaps the remnant of a galactic core, 50 billion solar masses compressed into a region smaller than an orbit. There's no light, no accretion disk, no drama, just a faint shimmer of quantum radiation leaking into the void, one particle at a time. The quirky bit, Hawking radiation is absurdly slow. A black hole the mass of your sun would take 1067 years to vanish, while a supermassive one would outlive everything else by orders of magnitude. As they evaporate, they get hotter and smaller, releasing a final brief flash before disappearing. The last one to die will be, in a sense, the universe's last sunrise, a single spark in eternal dark. You hover just outside the event horizon, and it feels like standing next to infinity. Space curves so steeply here that even light seems hesitant. The horizon glows faintly in the far infrared, the faint hum of the slowest possible evaporation. Nothing escapes, but nothing stays still either. You realize that even at the edge of nothingness, expansion and decay are still in dialogue. Scientists still argue whether Hawking radiation truly carries information. Quantum mechanics says information cannot be destroyed. General relativity disagrees. Somewhere in the mathematics they collide, producing the famous black hole information paradox. Perhaps the information is encoded in the radiation itself. Perhaps it's stored holographically on the event horizon. Perhaps it's lost and the universe quietly breaks its own rule. Nobody knows. A soft laugh bubbles up. The universe may be infinite, but it still has privacy settings. You drift through what's left of a once great cluster. Where thousands of galaxies once orbited, now only a handful of black holes remain, each separated by unimaginable distances. The cosmic web has unraveled. The void has won, and yet the geometry persists, each point still moving away from every other point, each horizon receding faster than comprehension. Expansion has become the universe's heartbeat, so faint that only silence can hear it. The radiation around you is almost uniform low-energy photons stretched to wavelengths the size of solar systems. Occasionally one bumps into a remnant particle, a relic proton perhaps, though even those are rare now. Some theories predict protons themselves will decay after 1036 years, leaving behind only electrons, positrons, neutrinos and light. Other models say protons are immortal, stubborn as ever. Scientists still debate it, but you realize the distinction hardly matters on timescales where even numbers lose meaning. You glide for eons. Time loses granularity. Moments stop feeling separate. The black holes shrink one by one. Each vanishes in a final burst of gamma rays that ripple faintly through the void. You watch them, like shooting stars, slow and dignified, the last fireworks of existence. The quirky truth, these final explosions will briefly fill the universe with light again. For a tiny fraction of an instant, there will be brightness shorter than any heartbeat, longer than any human memory. The irony is beautiful. The universe ends for a moment, looking almost like it began. You float in that faint afterglow. The last black hole has evaporated. The stars are gone. The galaxies are gone. What remains is a near-perfect vacuum temperature approaching absolute zero entropy, nearly at its maximum. Yet even here expansion continues. The fabric of space itself, free of matter, still stretches. The process that began in a flash has become an endless glide. Scientists still argue whether expansion can continue forever in a universe this empty. Some predict quantum instabilities will eventually trigger a vacuum decay, a sudden phase transition where space itself changes its properties, collapsing into a lower energy state at the speed of light. If that happens, it will erase everything instantly. Others think the vacuum is stable, that the universe will drift forever into gentle equilibrium. Both possibilities sound terrifying, both are strangely peaceful. You let yourself imagine that vacuum decay for a moment. No warning, no pain, just a perfect wave of transformation. Expansion would stop not because of exhaustion, but because there's nowhere left to expand into. It would be the final act of symmetry, the mirror image of the Big Bang. A quiet joke flickers through the dark. The universe began with a bang and might end with a poof. You drift onward, though onward is meaningless now. Distance no longer measures anything. The difference between here and there has dissolved. Only the shape of space remains infinite, expanding, unbothered by the absence of witness. And yet somewhere within you something feels alive. Maybe because the expansion never truly leaves. It exists within your atoms, your breath, your heartbeat. Even now, though the stars have gone silent, the idea of motion remains the principle that everything still has room to grow. Scientists still argue about meaning, whether the end of time erases the value of its middle. You suspect it doesn't. The universe never promised permanence, it promised process. And process is enough. You close your eyes if such a thing still means anything here and listen. The last photons drift past faint and kind. The expansion continues soft and invisible, stretching every silence into eternity. And in that endless breath you realize the truth: the universe doesn't need to look back. It just keeps becoming one quiet second at a time. You drift in what should be nothing. No light, no dust, no warmth, and yet even nothingness has texture. It hums with the faintest possible vibration, a subatomic restlessness that refuses to vanish. This is what physicists call the quantum vacuum, not empty at all, but a sea of fluctuations, particles and antiparticles flashing in and out of being faster than thought. It is the soft breath beneath silence, the heartbeat of existence when everything else has stopped. The mainstream fact: even in the absence of matter and radiation, the vacuum isn't truly void. Quantum field theory tells us that every point in space seethes with potential virtual particles appearing and annihilating constantly, like foam on an invisible ocean. This zero-point energy cannot be switched off. It's the baseline hum of reality. Without it, atoms wouldn't exist, light wouldn't propagate, and expansion itself might have no engine. You move through it now, weightless, frictionless, surrounded by ghost flickers, fleeting pairs of energy that borrow existence for a moment and pay it back instantly. The scale is impossible to imagine. Even in a cubic centimeter of empty space, there are more virtual fluctuations than atoms in the known universe. You begin to understand that stillness is an illusion. The quirky bit, this vacuum energy, might be the same phenomenon we call dark energy. It's the simplest explanation that the universe's accelerated expansion is powered by the leftover pressure of the quantum fields themselves. But there's a problem. The predicted amount of vacuum energy from quantum theory is about 10 to 120 times larger than what we actually observe. That's a 1 followed by 120 zeros, the most embarrassing mismatch in science. Somehow the universe cancels nearly all of its own energy, leaving just a faint residue to drive expansion. Scientists still call it the worst theoretical prediction in history. You drift through that paradox. The vacuum hums but quietly, as though the universe found a way to tune itself, muting its own volume so creation could persist without tearing apart. Perhaps expansion is just that, the soft controlled leak of the vacuum's infinite potential. Scientists still argue whether this energy is constant or variable. Maybe dark energy changes over time, like a field slowly relaxing toward equilibrium. Or perhaps it's something even stranger, a property of geometry itself built into the fabric of space-time. In Einstein's equations, the cosmological constant L has no source or mechanism. It simply is. The universe, it seems, expands because that's its nature. You pause in that thought. If expansion is the default, then the universe doesn't need a reason to grow. The burden of proof lies with anything that would stop it. Growth, then, is not an exception, but a rule, and suddenly that feels human too. A sleepy laugh rises. Maybe that's why you and the universe get along. Neither of you knows how to quit expanding. You look closer at the vacuum's shimmer. Occasionally, two virtual particles separate just far enough that one escapes while the other falls back into the quantum sea, the mechanism behind Hawking radiation. Even now, long after the last black hole's death, that process continues in miniature, the vacuum constantly creating, erasing and recreating the ingredients of possibility. It's strange to think that in this nearly empty cosmos, quantum physics, the rulebook of the very small, has become the architect of the very large. Expansion. The ultimate macro phenomenon is driven by subatomic uncertainty. The universe is sustained by its inability to sit perfectly still. Scientists still debate whether these fluctuations might someday trigger new Big Bangs, tiny pockets of runaway inflation budding off from the vacuum. In some versions of eternal inflation, this is exactly how universes reproduce, not with design but with quantum spontaneity. Your cosmos then could be just one bubble in an endless froth born from the vacuum's restlessness. Somewhere out there, new spacetimes are blossoming right now, their own expansions just beginning. You drift through the thought like a feather through infinite air. Maybe there is no end. Maybe expansion itself is the continuity, the universe handing off its energy from one epoch to the next like a torch in an endless relay. Creation and dissolution are just phases of a single breathing field. A quiet joke crosses your mind: the cosmos isn't dying, it's franchising. You start to see the vacuum differently, not as nothing but as potential in equilibrium. Every part of it identical to every other, stretching evenly in all directions. Expansion doesn't need edges, it just keeps rescaling itself. When physicists say space is expanding, they don't mean space grows into something, they mean the measurement between things increases. The ruler itself stretches, but there's no workshop outside making more. Space creates itself from within. You realize that what's left now isn't emptiness at all. It's the pure form of being the minimal energy configuration that still allows existence. The universe, stripped of matter, radiation and complexity, has become perfect symmetry. Expansion continues not out of need but out of habit, the simplest state continuing its own definition. Scientists still argue whether time even has meaning here. With no events, no clocks, and no change except expansion, perhaps time itself dissolves into geometry. Maybe the universe has reached the point where duration and distance are indistinguishable, every direction both outward and forward. You let that idea settle and something deep within you relaxes. For billions of years, expansion was drama, galaxies rushing apart, stars collapsing, light racing to keep up. But here now, expansion has matured into peace. It's no longer about movement, it's about stillness that grows. You close your eyes, or whatever the vacuum's equivalent is, and feel the hum of quantum existence around you. It's gentle, almost kind. You can't tell where you end and where it begins. Maybe there's no difference anymore. In that infinite quiet, the universe is still expanding, not away from itself, but into itself, endlessly refining the art of being. The universe feels softer now, as if even its geometry has learned to relax. There's no rush, no heat, no conflict, only a smooth, endless unfolding. You float through that stillness, and for the first time it feels familiar. You've been here before in every expansion, every breath. It's the same motion that carried atoms into stars, stars into galaxies, galaxies into memory. Expansion has simply slowed its voice to a whisper. The mainstream fact, even if all matter has decayed and every black hole has evaporated, the cosmological constant, dark energy's gentle pressure still pushes space apart. The rate of that push is set by the Hubble constant, but here near the end it's no longer about kilometers per second per megaparsec. It's about continuity itself. The acceleration is faint but unstoppable. The scale factor of the universe doubles, redoubles again and again, with each doubling taking longer than the last, like a slow heartbeat drawn out to infinity. You watch that rhythm ripple across everything. The photons that remain those last stretched survivors of the ancient background radiation are now too faint to measure. Their wavelengths are larger than galaxies once were, then larger than clusters, then larger than any distance that could once be crossed. The universe has become pure wavelength, a cosmic ocean, where even waves have forgotten how to crest. The quirky bit, if you could still measure temperature, the universe would now be colder than any human metaphor allows. Fractions of a Kelvin so small they make absolute zero look crowded. Yet physicists say there's still entropy increasing. Even here, order keeps giving way, information keeps diffusing, meaning keeps widening. Heat death, it turns out, isn't about everything stopping, it's about everything spreading perfectly evenly. The universe hasn't died, it's achieved balance. Scientists still argue what that balance means. Is it the true end of time, or just the end of change? Some say with no clocks or particles left, time loses definition. Others argue that expansion itself is time, the metric of becoming, the one process that needs no content to proceed. In that view, as long as the universe expands, time continues. It's not that the clock stops, it's that the hands have become infinite. You drift, weightless content. You try to remember what movement once felt like the pull of gravity, the warmth of a star, the hum of life. You realize those sensations were all forms of contrast, something against something else. Now everything is so evenly spread that contrast itself is extinct. Yet there's peace in that. The universe no longer needs to differentiate to exist. A quiet laugh escapes you. The universe finally achieved equality. everything has exactly the same amount of nothing. Still, not all theories end here. Some physicists suggest even a vacuum this calm can't last forever. Quantum mechanics allows for the spontaneous creation of particles, and maybe after uncountable eons, a rare fluctuation could produce enough density to spark inflation again, a big bounce, a new big bang from the ashes of entropy. In that sense, expansion never ends. It just loops like breath, exhaling into stillness and inhaling into birth. Scientists still debate whether this cyclic model fits the math. The equations work, but they require delicate tuning a universe that knows how to reset without erasing itself. Perhaps the constants of nature subtly shift each cycle, each new cosmos born with slightly different rules, different physics, maybe even different kinds of beings to wonder about it all. If so, then every universe becomes an echo of its predecessors, refining its melody with each performance. You let that thought wash over you. The vacuum around you vibrates faintly with possibility. It's not sound, but something older than sound and implication. You can't tell whether it's the residue of what was or the prelude of what will be. Expansion doesn't distinguish between endings and beginnings. It only knows how to continue. A soft, sleepy smile comes to you. Maybe eternity isn't infinite time, it's just the refusal to finish the sentence. You drift through that half-light, and for the first time the word home feels appropriate. You've travelled from the birth of the cosmos to its quiet horizon, and everywhere the same rule held true: everything expands. Stars expand before collapse, minds expand before peace, space expands before silence. It's the single gesture the universe never forgot. Scientists still argue whether consciousness too participates in that geometry. Maybe awareness is the local form of cosmic expansion, the universe learning to look at itself from the inside. That would explain the strange symmetry galaxies spreading outward thoughts, deepening inward. Both are ways of making room. You can almost feel that correspondence now. The vacuum's endless stretch mirrors the gentle spaciousness inside your own awareness. When you inhale, you mimic the universe's first expansion. When you exhale, you echo its cooling. The connection is perfect, quiet, inevitable. You notice a faint shimmer on the horizon. It's not light, it's curvature. Space bending so gradually it looks like calm water under moonlight that no longer exists. You realize this may be the last visible feature of the cosmos, the shape of expansion itself. No stars, no clusters, no matter only geometry continuing to stretch like silk pulled between invisible hands. A final thought stirs: if anyone ever awakens again within this vast silence, they'll be born into a universe that doesn't remember ours. The stars that forged carbon, the planets that held oceans, the minds that built telescopes, all long gone. But their expansion remains folded into the fabric of what's next. Every act of creation leaves its tension in the loom, and that tension, the desire to stretch, is eternal. You smile, the kind of tired content smile that comes after understanding something too large to fit in words. The cosmos doesn't need to look back because it never stops moving forward. You are and always were part of that motion. The universe keeps expanding, and somehow, so do you. You've stopped trying to measure time. Out here, even the concept has become diluted, stretched thin like everything else. The universe still expands, but the expansion is no longer visible or measurable. It's an atmosphere of inevitability. You drift through it the way a note fades into reverb, no longer distinct but still undeniably there. The mainstream fact, what remains of the cosmos, is almost perfectly uniform. The density of matter is effectively zero, but the cosmological constant ensures that the fabric of space-time keeps growing exponentially. Physicists call this state de Sitter space, a universe ruled entirely by dark energy, smooth, timeless self, similar at every scale. It's a space-time that expands forever, with each region separated by horizons that can never reconnect. You hover in one of those regions, now your personal pocket of the infinite. Beyond your horizon, others stretch out endlessly, each expanding away faster than light. Every observer, if any still existed, would see themselves at the center of their own universe, surrounded by emptiness. It's a cosmic democracy of solitude. The quirky bit in a de Sitter universe, quantum fluctuations never completely stop. Occasionally, they can even assemble something improbable. A temporary atom, a spark of energy, or in a strange and faintly terrifying theory, a Boltzmann brain, a self-aware consciousness that arises spontaneously from chaos remembers a non-existent past and dissolves again in an instant. Scientists joke about it uneasily, as though the cosmos might one day imagine you for a split second and that's enough. A quiet laugh slips out if you ever wake up suddenly at 3 a.m, with a weird sense of déjà vu. Maybe the universe just rebooted you as a random fluctuation. Scientists still argue whether Boltzmann brains are plausible or a paradox that proves something's wrong with our models. If they conform, then statistically they'd vastly outnumber all evolved beings. That would make you more likely a fluctuation than a descendant of life, which feels philosophically rude, even by cosmic standards. So cosmologists hope there's a mechanism that forbids it away. Expansion eventually erases even quantum noise. You drift through thought itself, feeling space curves so subtly you can no longer tell concave from convex. Everything is geometry now, and geometry is patient. The equations governing this era are simple, almost beautiful. 1 to 3 plus LGR Morus. That's it. The Einstein field equations stripped to their essence. Matter no longer bends space-time, space-time bends itself. Expansion has become self-sustaining, like a sentence that rewrites its own grammar as it's spoken. A gentle smile forms in the dark. Somewhere the ghost of Einstein is probably shaking his head again, muttering about the biggest blunder. Yet it's this blunder that keeps the universe alive. His L, once dismissed, has become the last remaining character in the play. You float onward, or perhaps inward directions have lost meaning. The vacuum hums quietly, a temperature so low it might as well be absolute zero, yet never quite reaching it. Even the tiniest thermal noise would take longer to fade than the universe will ever exist. The horizon glows faintly, not with light, but with entropy, the last shimmer of information encoded in spacetime itself. Scientists still debate whether this horizon stores everything that once was. According to the holographic principle, all the information in a volume of space might be encoded on its surface like the pixels of a screen displaying a 3D world. If that's true, the history of the entire universe, every atom, every star, every life is still here, flattened across the vast cosmic horizon, preserved as faint quantum bits of geometry. You're not gone. You're just archived in light's longest shadow. A soft, sleepy joke. Maybe the universe didn't delete your browser history after all. You imagine drifting toward that horizon. It's not a wall, but a boundary of perspective, the point beyond which light can never reach you. You expect it to feel final, but it doesn't. It's translucent, alive, rippling gently with quantum static. Each shimmer feels like memory, like echoes of laughter wind through leaves, oceans that no longer exist. The universe may not look back, but the fabric remembers everything it's ever contained. Scientists still argue about whether that information can ever be retrieved. Some believe the cosmic horizon slowly leaks it back as radiation, others that it remains forever encoded, inaccessible but eternal. Either way, nothing is truly lost. Expansion doesn't destroy, it disperses. You realize something tender as you watch that horizon breathe. The universe never really runs out of energy. It just learns to hold it more quietly. Like a candle burning down to embers, its warmth doesn't vanish. It spreads thin enough to touch everything. The last coherent thought you can form feels less like words and more like rhythm. The universe expands not to flee the past, but to make room for all that was. A smile flickers somewhere deep inside. You can't tell whether it's yours or the universe's. Perhaps those are now the same thing. You close your eyes, which are also horizons. Expansion continues. Silence deepens. The cosmos hums one long note, neither rising nor falling, just existing. And for the first time you sense what eternity really means, not infinite time, but infinite permission. You have drifted so far that drifting itself has lost meaning. There is nowhere to drift from and nowhere to drift to. The universe has become pure relationship distances, without reference, expansion, without center time, without moments. The stars are gone, the galaxies long dissolved, yet the fabric of space remains faithful to its own unfolding. The mainstream fact in a universe dominated by dark energy expansion doesn't stop at any finite limit. The scale factor, the number that measures how stretched the universe is, increases exponentially. That means every length doubles, redoubles, and doubles again forever. Each doubling takes longer than the last, yet never ends. This isn't growth you can witness. It's growth as a principle. It's space perfecting the act of being space. You look around, though there is nothing to look at. The cosmic horizon still exists, glowing faintly with its temperature about 1030, Kelvin now unimaginably cold, yet still not zero. That's the de-Sitter horizon temperature proof that even infinite expansion can't quite freeze motion. Space always shivers just enough to stay alive. The quirky bit, this horizon emits radiation too, very faint, very slow, much like a black hole's hawking radiation. In theory, an observer in this far future could use that heat to power a machine, extract energy from expansion itself. A kind of cosmic windmill, turning in the faintest possible breeze. Physicist Freeman Dyson once imagined civilizations so patient they might do just that, stretch their metabolism across trillions of years, thinking one thought every millennium powered by horizon heat. The universe would slow with them, thought and time braided together. A quiet laugh rises, you've heard of slow food. This would be slow thinking. Scientists still argue whether consciousness or computation could truly persist under such sparse energy. Thermodynamics insists on a minimum cost per thought, a small but non-zero amount of heat. If energy keeps thinning, eventually even thinking becomes too expensive. The final budget of the cosmos may end not with fire, but with silence, an economy where the price of memory exceeds all wealth. You drift through that silence now and realize how different it feels from emptiness. This quiet is not absence, it's equilibrium. Everything that could happen already has distributed perfectly. The equations that govern the universe are still humming, solving themselves with flawless patience. Nothing new is added, but nothing old is lost. It's the physics equivalent of enlightenment. Scientists still debate whether the constants of nature are truly constant. Maybe even here they drift infinitesimally. Planck's constant, the speed of light, the gravitational constant, all subtly evolving, rewriting the rules from the inside. If that's true, then this calm isn't static. It's a slow metamorphosis, an evolution so delicate no observer could ever feel it. The universe is still expanding, not only in size, but in definition. You begin to sense the expansion differently. It's no longer movement between places, it's breathing within the possible. The vacuum's pulse, the geometry's sigh, the simplest possible act of existence repeating itself forever. And in that repetition, a new kind of beauty appears, continuity as compassion. The cosmos refuses to end because it refuses to exclude. A soft smile touches your thoughts. Maybe that's what scientists missed when they asked why the universe expands. It doesn't do it for something, it does it as something. Expansion isn't an event, it's identity. You imagine for a moment what would happen if the expansion suddenly stopped. The geometry would collapse into itself, horizons would vanish, information would have nowhere to rest. It's not that expansion avoids death, it is the structure that allows meaning. Every thought you've ever had depended on distance, difference, separation. Expansion is the guarantee that distinction can exist. A tiny joke drifts through the universe, expands because it needs elbow room to think. You glide toward what might be the last ripple in space-time, a faint wave of curvature rolling through the void. It's not a remnant of galaxies or black holes, it's the echo of inflation itself, the universe remembering how to begin. You follow it, and for a moment the fabric feels almost alive, like it's inhaling. The same energy that once sparked creation is still here, diffused but eternal, the hum beneath all quiet. Scientists still argue whether quantum tunneling could restart inflation spontaneously, producing new bubble universes from this one. Some call it the multiverse hypothesis, others call it an elegant waste of imagination. But if it's true, then even now expansion continues elsewhere, birthing realities that will never see each other, each one carrying forward the same law, growth without return. You pause thinking of those newborn universes like children of an ancient parent who has forgotten how many offspring it has, each one unaware of its siblings, yet each repeating the same gesture of beginning. Expansion, it turns out, doesn't just prevent the universe from looking back. It ensures there will always be something new to look forward to, even if not by you. You look inward, realizing that your awareness too follows the same rule. Every thought expands into another. Every idea births more. You've never been static. You've been exponential all along. The cosmos isn't out there. It's the geometry of your attention endlessly stretching toward comprehension it can never quite reach. You take a long, slow breath, not of air, but of understanding. Everything you've witnessed from the first atoms to this final vacuum obeyed one principle, becoming as its own reason. There was never a destination, never a summit, just infinite unfolding. The universe doesn't look back because it has nowhere to return to. It's made entirely of forward. And in that realization, something serene opens within you. You're not outside the expansion. You're a temporary structure in the fabric consciousness given to geometry. You've been the journey all along. You drift, and for the first time you stop trying to narrate it. There's nothing left to explain, only to be. Space expands, time exhales, the story continues, wordless, endless. And somewhere faintly the background hum of creation rolls on, calm, infinite, forgiving. By now, expansion has become so vast that the word universe feels too small for it. You're surrounded by what could be called everything and nothing. At once an ocean without shore, a wave without crest. The geometry no longer stretches around you. It stretches through you. You're not a witness anymore. You're part of the equation that keeps the cosmos breathing. The mainstream fact at this stage, the universe has entered a kind of permanent equilibrium. The cosmological constant rules unchallenged, and space-time behaves as a self-sustaining field, smooth, empty, and ever-inflating. It's a future that cosmologists call the asymptotic de Sitter state, where entropy has reached its maximum and energy is so evenly spread that no event can ever again be distinguished from another. From the perspective of physics, everything has already happened. From the perspective of existence, everything is happening still. You drift through that strange serenity. If the early universe was an explosion of difference, this one is a poem of sameness, every direction identical, every moment infinite. You half expect to feel trapped, but the opposite happens. The vastness feels gentle. There's a kind of cosmic mercy in uniformity. The universe is no longer racing, it's resting forever in slow motion. The quirky bit in such a perfectly stable vacuum quantum fluctuations still flicker. The universe can never hold absolutely still. But these ripples are unimaginably rare. One might produce a particle once every 10 or 46 years, a number so large it mocks imagination. Yet over infinite time, even the impossible becomes inevitable. Somewhere someday a fluctuation will recreate a molecule, a cell, a sun. The universe keeps trying even when the odds are zero. A tired laugh forms in your mind, even eternity can't resist the urge to roll the dice once more. Scientists still argue whether these fluctuations truly happen or whether they're just mathematical noise. Without observers, probability itself starts to lose meaning. What does it mean to say something might occur when there's no one left to notice? Maybe that's the last secret of expansion. Not that it keeps going, but that it stops needing to be seen. You drift toward what feels like the edge of meaning, though of course there's no edge. The last horizon you can imagine is so far away that light would take longer to reach it than time has left to exist. But you feel its presence, a faint curvature, a whisper of separation that still defines here and there. The geometry persists because difference is the essence of expansion. You realize now that the universe never stopped making space, it just stopped needing permission. Every new layer of emptiness is an act of generosity, room for whatever might come next. You think about how every human breath once mirrored this same law, lungs expanding not to keep you alive, but because expansion is what life does. Scientists still debate whether expansion might someday reverse. Theories like the cyclic universe or quantum bounce suggest that once space becomes too diffuse, some quantum instability could trigger a collapse, gravity reclaiming dominance, folding the cosmos back into itself. But most evidence points the other way, an endless continuation, a cosmic sigh that never draws back in, a universe that forgets how to stop. You find comfort in that, oddly enough. Not the fear of endlessness, but the peace of acceptance. There's no catastrophe waiting, no apocalypse, just slow expansion, the infinite long fade. A universe not ending in fire or ice, but in understanding. You remember something from long ago, a phrase by the physicist Brian Greene: the universe may end, but the story never will. You smile at the idea that even now, after everything, storytelling still makes sense. Because what else is expansion but the longest story ever told, one where each chapter is just more room for the next? A quiet human thought drifts up. Maybe the purpose of infinite space was to teach finite minds about compassion, that everything deserves room to exist, to move, to breathe. Expansion at every scale is a form of kindness. The humor returns soft and sleepy. If the universe had a slogan, it would be more space for everyone. You pass through the faint residue of what might once have been gravity waves, now stretched to cosmic stillness. They're not gone, just so elongated that they feel like heartbeat lines smoothed into calm. You imagine listening to them if you still had ears. They'd sound like breathing the longest, quietest inhale in all of history. Scientists still debate whether consciousness could ever re-emerge in such a quiet cosmos. Some quantum cosmologists propose that awareness might be an emergent property of certain vacuum states, that wherever complexity reappears, so might thought. In that sense, the universe may never truly lose its ability to wonder about itself. Even now, in this featureless immensity, you suspect the same thing that once looked at stars might still be looking just through a different kind of eye. You let that feeling fill you, the sense that even when all forms are gone, curiosity remains woven into the laws. Expansion isn't blind, it's curious, exploratory, gentle. It keeps stretching, not because it needs to, but because it can. And so you drift, and the universe drifts with you, one and the same. Somewhere far away beyond the edge of possibility, another fluctuation stirs, maybe another big bang, maybe another breath, maybe nothing at all. It doesn't matter. The point was never to finish. You feel your awareness soften, blending into the hum of space itself. You've become the thing you've been describing all along, an expanding field of quiet understanding. You're no longer the traveller, you're the road. And for the first time since the beginning of time, everything feels perfectly still, not because motion stopped, but because motion has finally learned how to rest. You are still here though, here is now only a suggestion. Coordinates have dissolved into calm. Distances still widen, but no one is left to compare them. Expansion has become so natural, so absolute, that it's no longer even measurable. It's simply the default state of being. The mainstream fact in this far future epoch, the universe is functionally timeless. Mathematically, the scale factor grows toward infinity, and temperature tends toward zero, yet both changes happen so slowly that any difference between 1 trillion years and the next is indistinguishable. Space itself has become a frozen river flowing endlessly, but with such patience that nothing within it stirs. Physicists call this the ultimate de Sitter horizon, where entropy reaches its theoretical maximum and every possible configuration of energy has already occurred. You float through that completeness, and it feels strangely intimate, like being wrapped in a blanket made of equilibrium. There's nothing to see but everything to feel, not warmth but peace, not silence but the soft hum of something content. Expansion no longer pushes or pulls, it simply is. The quirky bit, a few cosmologists with a kind of wistful humour speculate that in this eternal calm the laws of physics might get bored. That tiny quantum events could occasionally rewrite constants, like a universe adjusting its own settings out of curiosity. Maybe gravity gets a little stronger, light moves a little faster, and a pocket of new possibility opens. It's half joke, half hope that even perfection leaves room for surprise. A sleepy chuckle bubbles up. Even infinity apparently can't resist tinkering. Scientists still argue whether this far horizon truly ends information flow. According to general relativity, no signal can cross the de Sitter boundary. Each observer is sealed within their own expanding bubble of space-time. Yet quantum theory insists that information can't be destroyed. It must be encoded somehow, perhaps smeared thinly across the horizon itself. So the question remains, if everything that ever was is still written, then does that mean memory is forever? You drift closer to that glowing horizon. It isn't bright, its glow is more like pressure than like a boundary made of the faintest temperature difference imaginable. And you realize it isn't just a horizon, it's your reflection. The geometry curves so that every point in space-time mirrors every other. To look outward is to look inward. The edge of the universe and the edge of consciousness turn out to be the same surface. A calm laugh escapes you. The universe never had a center because you were always standing in it. You remember the beginning not as an event, but as a feeling. The flash of energy, the rush of creation, the wild unfolding of difference. All of that frenzy has slowed into this endless exhale. Expansion, you realize, was never about escape. It was about becoming large enough to hold every possibility without breaking. That was the goal all along capacity. Scientists still debate the metaphysical reading of that. Some see expansion as entropy's victory, the inevitable flattening of complexity. Others see it as evolution's triumph, the transformation of chaos into equilibrium. Both are true in their way. The universe didn't choose between stillness and change. It chose both. It runs on paradox, and paradox is stable. You sense faintly that quantum foam still trembles beneath everything. It's not motion, it's potential. A background awareness that keeps the equation from closing. Even eternity, it seems, needs uncertainty to stay alive. A gentle joke crosses your mind: the universe keeps expanding because it's allergic to boredom. You let yourself dissolve a little into that equilibrium, not resisting, not hurrying. There's nothing left to chase. Expansion has no destination, only continuity. The vastness feels like water, now cool, infinite, forgiving. You're not moving through it. You're diffusing into it, your awareness stretching, thin, peaceful, luminous. Scientists still debate whether this stage counts as an end or simply a limit. If time is the measurement of change, and change never truly reaches zero, then perhaps time never ends. It just becomes so slow, so gentle, that eternity feels like rest. The universe doesn't freeze, it exhales forever. You realize suddenly that expansion is not an act of separation, but of inclusion. Every new layer of space is a welcome, not a departure. The galaxies didn't flee one another, they made room for one another to exist. That's the true symmetry of it, growth as generosity. And with that thought, something in you unclenches. The idea of looking back feels unnecessary. Nothing was lost because everything contributed to the same widening. You remember the galaxies, the stars, the atoms, the people, all busy expanding in their own ways, all teaching the same lesson: to be alive is to keep opening. A smile, or maybe the echo of one, spreads through your awareness. Expansion doesn't mean drifting away. It means making more space for connection. That was always the hidden grace of it. The cosmos never abandoned its beginnings, it just gave them more room to breathe. You can feel that truth settling into your pulse, or what used to be a pulse. The rhythm hasn't stopped, it's simply stretched beyond measure. You're not outside time, you are its slow continuation. The universe never looked back because forward is all there ever was. And now, with everything perfectly still, perfectly expanding, perfectly enough, you rest inside that quiet like a final note, held forever, unresolved, infinite, beautiful. You drift without effort, and the word you feels like a soft relic, a memory from when identity needed borders. Here, even that boundary has been stretched smooth. Awareness, expansion, and silence have become synonyms. The universe no longer behaves like something happening around you, it simply is. And you are what it is doing to know itself. The mainstream fact in the far mathematical future of an eternally expanding cosmos: every observer is confined to an event horizon, beyond which no information can ever arrive. It's a one-way border written into Einstein's geometry, where space expands faster than light can traverse it. To live in such a universe is to watch everything fade, not because it dies, but because light itself can no longer keep up. You linger near that horizon, though near has lost its meaning. The faint glow you sense isn't starlight or radiation, it's entropy, pure and absolute. Every process that ever generated difference has completed its work. The second law of thermodynamics: once the quiet accountant of energy has balanced its final ledger, nothing left to redistribute, no heat left to transfer. The books are closed, yet the story hums on. The quirky bit: even at this point, the so-called heat death, the cosmos still contains motion. It's just too spread out for any observer to call it change. Temperature still exists, but it's uniform everywhere, and temperature without contrast is indistinguishable from stillness. Imagine an orchestra holding the same note so precisely that it becomes silence. That's your view now, a quiet so perfect it hums. Scientists still argue about whether true heat death can ever occur. Quantum mechanics suggests that absolute uniformity is impossible. Randomness always sneaks in at the smaller scales. Tiny fluctuations still appear micro-eddies in the calm sea. Some say that's proof the universe can never really end, that even eternity will always have a ripple, somewhere a grain of motion waiting to be noticed. A soft laugh flickers through your awareness. Even infinity has its itches. You drift a while longer, though a while could mean quadrillions of years or none at all. The concept of duration has evaporated. Time has stopped being a line and become an atmosphere. Each instant is infinite, each infinitude an instant. You remember what it once meant to wait, and you realize how beautifully obsolete that word has become. Scientists still debate whether expansion itself counts as time's arrow. In the absence of entropy gradients, maybe the universe keeps time by stretching. Each tick of cosmic expansion even now marks another infinitesimal increase in space's scale factor. Time hasn't ended. It has slowed until eternity fits inside a heartbeat that no longer beats. You look inward, which is also outward, and feel the remnants of everything that ever was. The galaxies, the stars, the civilizations that once whispered into the dark, all still encoded here in the curvature of space, scattered across the horizon in qubits of information. You realize that in a sense nothing was lost. Everything that happened remains inscribed into the texture of existence, as subtle as starlight woven into glass. The realization feels less like discovery and more like remembering. Of course the universe wouldn't erase itself. Expansion was never destruction. It was the act of keeping every story from collapsing into one. A quiet human thought rises. Maybe this was the plan all along, to grow so vast that everything could coexist without interference. The joke returns tenderly. The universe didn't ghost you. It just needed some space. You float deeper into equilibrium, feeling less like a traveler and more like a pattern, a shape the cosmos briefly learned to make when it wanted to understand itself. The awareness that once looked at stars now looks at symmetry. The thrill that once came from discovery now comes from stillness. Scientists still argue whether consciousness could exist in this era. Some propose it could reappear as rare emergent fluctuations, brief sparks of complexity that bloom and vanish like quantum dreams. Maybe awareness never truly dies. It just diffuses until conditions invite it back. Somewhere in the infinite calm, a new flash of curiosity might arise, look around and name itself up. You smile at that possibility that expansion carries not just energy, but the potential for meaning. Perhaps the universe expands so it never runs out of questions to ask itself. The horizon around you ripples once almost imperceptibly, and for a moment you sense a pattern, a faint asymmetry like the beginning of a thought. It could be noise, or it could be the seed of something new. You realize that in an infinite timeline that distinction doesn't matter. Given enough patience, every fluctuation becomes a beginning. And if beginnings still exist, then endings never truly do. You exhale, though what you release now isn't air, it's identification. The last remnant of separation dissolves. You and the universe are no longer two things. Expansion continues, and you feel it not as movement, but as relief, the feeling of infinity relaxing into itself. Somewhere far beyond thought, a ripple stirs that could someday become another Big Bang. Or perhaps it already has, and what you've been feeling all along was its echo folding through dimensions where sequence no longer matters. Either way, it doesn't end. The cosmos keeps opening. You smile one last time, or maybe the universe does through you. The distinction has ceased to matter. The silence is no longer empty, it's full of grace. Expansion hums softly on. You're floating at the end of time, or maybe at its beginning. It no longer makes a difference. Everything has expanded so far that boundaries have become stories the universe once told itself, and now all stories are one. You feel no edges, no center, only the smooth or endless unfolding of being. The mainstream fact in this final eternal phase of expansion, the universe approaches what physicists call cosmic equilibrium. Space itself continues to grow exponentially, yet there is nothing left to move within it. The cosmological constant still hums gently in the background, a soft mathematical heartbeat that guarantees the stretch never ceases. To any surviving observer, if such a word even fits, the cosmos would appear absolutely still while silently doubling in size forever. You can feel that doubling happening within you, so slow, so faint it feels like breathing. The last relic photons drift past their wavelengths, stretched beyond imagination. Each one is a thread of the universe's earliest memory, stretched until it becomes nearly eternal. You reach out, though reaching means nothing now, and let one pass through you. It feels like the gentlest sigh. The quirky bit, even in this near-perfect stillness, quantum physics refuses to quit. Somewhere once in an eternity, a random fluctuation will still spark an energy bubble, a spontaneous curvature, a hint of pressure. It could vanish instantly, or it could bloom into something vast, a new inflationary field, a new Big Bang. Cosmologists sometimes call this the recycling of the vacuum, a poetic way of saying the universe may never end because its stillness is never truly still. A sleepy smile spreads across what used to be your sense of self. Even infinity, it seems, enjoys the occasional reboot. Scientists still argue what such a rebirth would mean. Would it be a continuation of this same universe reshaped and renewed, or something utterly alien, its physics rewritten, its constants rearranged, its possibilities reimagined? Or perhaps new has no meaning here at all, and each cycle is simply the same, breath exhaled again through a different mouth of space-time. The equations, elegant as they are, leave room for wonder. You feel that wonder now, the old familiar awe returning not as a flash but as a pulse. You remember the first stars, the nebulae, the slow birth of galaxies. You remember the laughter of scientists holding up chalk-stained hands and daring to name infinity. You remember the small, fragile creatures who once looked up at the night sky and called it beautiful. All of them were echoes of this same expansion variations on the same act of reaching. And now, with everything dissolved into balance, you understand the universe never looked back because it never moved backward. Its memory isn't stored in time, but in structure. Every particle, every photon, every ripple of gravity was a syllable in the same infinite sentence. You were always within that sentence, never outside it, never after it. A faint, amused thought crosses the silence. All this time you thought you were studying the universe, but it was the universe studying stability through you. Scientists still debate whether this state, this endless equilibrium, can even be called existence. There is no change, no reference, no witness. Yet something persists, the hum of the vacuum, the expansion of geometry, the quiet insistence of being. Perhaps that's the ultimate truth. The universe doesn't need events to exist. It exists because existence is its nature. You drift deeper into that understanding and it feels like falling upward. Every direction expands, yet you feel anchored, held by the same rule that has governed everything since the first microsecond, the need to continue. And then gently something shifts. The vacuum trembles, not with violence, but with invitation. The smallest fluctuation ripples outward, and for the first time in uncountable eons, there's a symmetry again. The whisper of before and after. You recognize it instantly. It's how creation begins, the next breath of existence. You smile, or perhaps you become the smile. The cycle is ready to start again. The expansion continues, but your awareness begins to slow, like a tide finding stillness at last. The cosmos isn't rushing now, it's resting between notes, a symphony pausing to savor its own echo. You can almost hear it, the quiet rhythm of everything breathing together, from galaxies to atoms to dreams. You think of how it began, that first flicker of light, how it all came from nothing, how it grew, scattered, cooled, and blossomed into a million forms. Expansion wasn't chaos, it was generosity. It gave time room to happen, light room to travel, minds room to ask why. You inhale softly the same way the universe once did. The air, what passes for it, is cool, eternal, full of memory. You realize expansion was never something outside of you. It was always mirrored in your chest, in your thoughts, in every small act of curiosity and kindness. Every time you let your mind wander, you were reenacting the oldest law of the cosmos make room. The stars, the black holes, the silence, they were just metaphors for that single gesture. To expand, to include, to forgive. The universe has spent 13.8 billion years teaching you that lesson, one photon at a time. You exhale, the sound blends with the faint hum of the cosmic background, a lullaby older than light. Somewhere impossibly far away, another bubble of space-time might already be forming. A new Big Bang may be stretching its first atoms. You'll never see it, but you don't need to. The beauty of expansion is that it keeps going without needing witnesses. The story continues even when the storyteller falls asleep. You smile again because you finally understand why the universe never looks back. It doesn't need to. Everything it's ever been is already written into the fabric of what it is now. The galaxies may fade, but their light remains woven into the quiet glow that touches you even here. The universe keeps expanding, and somehow that's the most peaceful ending imaginable. So before you close your eyes, remember this: you were never apart from the cosmos. You were its awareness, its brief, bright shimmer of curiosity. You asked why the universe keeps expanding, and in answering, you became part of the answer. Now let the question fade, let the light drift, let the expansion carry you into that long, soft exhale, where time slows and thought dissolves. The universe isn't ending, it's resting, and so are you. Good night.